like it even. It can also come from content data, from metadata that music is assigned to, like a genre or a social tag that users have assigned to the piece of music or to the artist. It can come from the signal information itself, from the audio track, from some Spotify has some great features like danceability of music. So this is also context that can be used in order to do personalization. However, even if music recommender systems have been around for a long time, and this is like a big companies are behind it, it's still not a trivial task to understand music preferences, because they're quite an interesting thing. So music preferences are shaped by the current emotional state. So if I'm very happy, I might want to listen to very uplifting music. The same is if I'm really sad, so I might listen to slow music. Music preferences strongly depend on the current context. So if I'm at work, I might listen to different music than if I'm on a party or studying. And there is, at least in Spotify and in Last.fm, so there's even like these playlists for running or for working. Music is also used to serve a specific purpose, like mood regulation. So I want to get in a good mood, so I listen to maybe some uplifting music. Personality has a strong impact on music preference. There has been lots of work, great papers, also by people here probably in this workshop who found out about these characteristic factors. Music psychology also tells us something else, namely that music liking is strongly or positively influenced by prior exposure to music. So if I have heard something in the past, I might develop a preference towards it. And this is called mere exposure effect, or familiarity principle. This is not only the case in music, but it's the case in general in preferences. So users over time tend to establish a positive preference for items that they are frequently and consistently exposed to. And we wanted to study this using a memory theory, because of course in our memory we also store information, and information that we are frequently and consistently exposed to might have a special place in our memory. This is the topic of today's talk. So how can we model it with memory theory? I want to give a brief overview of these concepts, because maybe not everybody is familiar with these theories and these models from psychology. So memory as such, of course, as computer scientists, we have a specific understanding of memory, but in context of cognitive science, it's a fundamental cognitive process. It's really crucial. With our memory, memory shapes our complete interactions with our physical and social environment. So we have information, we take this information up, we encode the information, store it in memory structures in our brain, with the aim to have then information that can be later retrieved in situations where we need this information. According to cognitive psychology, we have several memory structures, or different types of memory structures, like the short-term memory, working memory, and long-term memory, and in there different items are stored and retrieved with different processes. What's crucial to know is that when information is encoded in human memory, it's bound to a temporal and a spatial context. So you have some kind of context information in order to help with later retrieval when you want to retrieve your memory. And retrieval is then more or less a context-guided search of memory content. And there you might already see this relation to research in recommender systems or research in information retrieval, because this is really closely related to what we know from these fields of retrieving information. So this is like our computer science domain, but its memory is of course a classic research topic in cognitive science. There have been loads of research works, great research works, great models about memory. And I put here a link to a great overview of state-of-the-art of computational models of memory research, if you're interested to dive into this topic a little bit more detail. Just a few words about cognitive science. This is an exciting field, it's a multidisciplinary field with the aim to understand the functioning of the human mind. And of course, this cannot be done by just one single discipline. So there's people from AI working on cognitive science, people from neuroscience, cognitive psychology. What's great about cognitive science is that they typically follow a very empirical approach. So that means they do experiments, they collect behavioral data, and then they study this behavioral data using concepts from mathematical psychology, where you have the models, and the parameters of these models then represent cognitive constructs. So this is then nice as a computer scientist because we can build upon this math to create computational models. And currently, so the predominant approach I would say in cognitive science is cognitive computational modeling, where the aim is really to do this to go not only in lab studies but to do data-driven studies and to derive new models using data-driven studies. Human memory theory has been used a lot in recommender systems. I want to mention a few examples of the use of human memory theory in our community. So for instance, first line here, so there's a paper by Rutledge, Taylor and West on where they worked on a library information system, and they wanted to resemble how human experts make recommendations. And they employed a model of long-term memory to that end, and they really made a nice system where they showed that this works really nice. Then there's another paper that yeah, at least some of you know quite well, because it's a paper by my friend, where they investigated positivity effects in human memory. That's the impact of positivity on rating behavior. This paper I found very interesting because it builds upon this principle, this Pollyanna principle, so that memories become more positive over time. And you might know this from your own experience. So when you think about something that happened a long time ago, you more or less remember, you have a tendency to remember the more positive aspects of this memory. And they wanted to see if there's a correlation between that effect and rating behavior. And they found indications for the Pollyanna effect in offline studies, but in an online study, they found something completely different. So users tend to rate items worse if they have consumed it a long time ago. So there might be some different factor that contributes to that as well. And what's also interesting is another human memory model, namely the Ebbinghaus forgetting curve is often used in recommender systems research. And I find this interesting because it's a really old model. So it's like from 1800 or so. So it's still around. And in the end, it models, it describes the decrease in our ability of our brain to retain memory over a long time. And in the context of recommender systems, it's often used to model like changes in interests of a user as a negatively accelerated decrease in time. So that's interesting. So these theories have been around. Some of the theories have been around for a long time, but they are used in contemporary research. Memory is very often studied in the context of cognitive architecture. And the cognitive architecture is a tool or a type of framework often used in cognitive science to draw a more realistic picture of how different cognitive domains in the human brain work together in order to create like an emergent phenomenon, like coherent thoughts or learning or forming emotion or perception and stuff. I put here another link if you want to learn more about cognitive architectures to a survey that outlines different types of them, because of course many of them have been proposed. What I would like to talk more about is one of the cognitive architectures that is often used in recommender systems research, which is called ACT-R. And cognitive ACT-R, you can see it here in this bubble here. This is kind of like an abstraction of our mind works, or how we process information. And it consists of, it takes this computational metaphor, so which means like the mind or the memory is looked at as a form of information processing. information processor. So you have information that is encoded, that goes through a central register that is encoded in memory. You have these different memory modules, like the working memory, then the declarative memory and the procedural memory. All of them have different types of information in them. When you think working memory is what you know about is a common concept. So you what is the stuff is stored that you're currently using. The declarative memory, this is more like the facts, the factual information. And in the procedural memory, the information is stored how to do stuff. So like rules. It's more or less like rules on how to carry out how to write a back, for instance. And what's interesting about this cognitive architecture, ACT-R, is it models activation processes in memory. What does that mean? A memory unit, when it has a high activation, can be easier retrieved from memory. So something that you need to remember, hopefully has a high activation so that you can retrieve it from all the memories that are stored in the brain. And there's an interesting approach here, because the activation processes are modeled using the so-called activation equation. So AI is this here. And this composes of the base level learning equation, BI, plus an associative component. What does it mean? The base level learning equation describes in a mathematical form how important current information or memory unit is for a human in a specific setting. And the information unit or memory unit has a higher activation if a user has, or if it has been used frequently and recently, following a time-dependent decay in the form of a power law. This is this BI equation. So information that is used frequently and recently can be easier extracted from memory. So what has all of this to do with modeling music behavior, music listening behavior? I'll show you. So we did an experiment. So we wanted to understand music genre preferences. And in particular, we were interested in users that have different music consumption patterns. There are music listeners who like really popular music in a streaming platform. Then there are music listeners who really like niche music. So those are the ones that like music that nobody else likes, or only a small amount of people likes. And then there's people in the middle. That's what the three groups that we looked at. And our aim was, for each of the three groups, we wanted to have a model that helps us predict what genre a user is going to listen next, with the aim to improve personalization using insights from human memory theory. We employed a data set that is around, namely the last exam 1B data sets. It has been created by Markus Schädel from University of Linz, which is quite large data set. So it has a listening history of more than 20,000 users, 1.1 billion listening events, and it was crawled over a period of 9 years. So we know a lot about it. So we have lots of data and hopefully enough data to get more insights into music preferences. Also, the music in this data set is categorized into a free-based taxonomy of music genres. And this is a really fine-grained taxonomy, so it's not like rock, pop, and stuff, but it has more than 2,000 genres, and there's genres in there as I've never heard of, like Viking metal or something along those lines. So it's our aim was to really find out something about very specific preferences. Each event, so they call it listening events. So a user listens to a piece of music and produces a listening event. So we know for each listening event who listened to it, what artist that is, what album, what track name, and then we have a timestamp. So we can model the preferences over time. Plus, what's really great is they also feature a so-called mainstreaming score. And the mainstreaming score is defined as the overlap between what a listener has in his own personal listening history and the aggregated listening history of the community. So we know the preference of, so how far is a user from the mainstream of the community. And this mainstreaminess score is then the basis for us to derive different user groups. So because we wanted to see preferences of users who are not, whose preferences are not in the mainstream of the community, then users who are like in the midst of the mainstream of the community, and some who are in between. If you're interested in this data set and if you want to use it in your own research, we have made it available for the research community to use. So it's, here's the link where you can find the sample. The first, what we wanted to know, so we created this data set, so we have the equal distribution of users in low mainstream users, mid mainstream users, and high mainstream users. If you want to learn more about how we did that, this is in our, I would refer you to the paper. And first we wanted to know, so how coherent are these groups in them, within themselves. So we computed the pairwise user similarity of the users in the low mainstreamness group, in the mid mainstreamness group, and in the high mainstreamness group. And from these box plots, you might see that the high mainstreamness group, they have a rather higher pairwise user similarity. So they like to listen to the same genres. So they're quite similar to each other. So here, I mean, some kind of collaborative filtering approach should be working nicely for this group. Interestingly, for the low mainstreaminess users, this is not the case. So they don't have that much pairwise similarity. So they don't overlap so much. So they seem to have a more individualistic listening behavior, which is interesting, which makes them hard to target, of course. And the mid mainstreaminess users are in between, as expected. Then we wanted to see, are there some genres that are really dominating the user groups? Or, so like, does everybody listen to rock? Let's put it like this, yeah. And this is actually the case in the high mainstreaminess user group. So we see like a real steep slope, and the genres that high mainstreaminess users listen to are really like rock and pop. So this is like what they most consume. Also, the mid mainstreaminess consumers have some dominating genres, but interestingly, the low mainstream users, they don't have that so much. Yeah? Like the top genres for them are some stuff like metal music or heavy metal music, I think it's, and ambient music, but it's not as dominating. So we cannot learn so much about them by just looking at the top genres. Then we studied the temporal dynamics of the listening behavior. And we did it by looking at if they repeat their music consumption over time. So if they're re-listening to the same genres over and over again. And we plotted this on a log-log scale. So we plotted the re-listening counts of genres, so listening and listening again to the same genres, over the time since the last listening event of the genres. But you might see something interesting here, because all of them have a skewed distribution. We did a power law fit, so all of them follow a power law distribution. So all of them seem to re-listen genres if they have listened to it frequently and recently. And there we can now go back to our human memory theory, because this is exactly what is modeled in the space level learning equation. Because here, the more frequent and the more recent you have consumed the memory unit, the more important it is to you, and this follows the time-dependent decay in the form of a power law. So we see the same behavior, the same frequency and recency patterns in listening behavior as in our human memory. Of course, we thought, great, awesome, we build a computational model out of that and see what happens. So what we did is then, we created an approach called BLL. We computed the base level learning equation, the base level equation for a genre for a user using this equation here. since the outcome of this equation is not between 0 and 1, we normalized it using a softmax function, and we use this in order to predict the top genres that have the highest activation for the user. The outcome of that was, when comparing these two baselines that we also used in the same setting, is that for all user groups we outperform baselines. And then I shall say a few words about the baselines. I mean, so we have seen that the groups are somewhat similar in between. So we looked at this pairwise user similarity. So we thought that a CF algorithm, a collaborative filtering algorithm, should be able to segment the groups sufficiently well. We've seen that for some, so for the high mainstreamers, there were some dominating genres, so popularity should also be a good feature in order to model the listening behavior. And this is also true. We saw that time has an impact, so the time is one of a good feature and a good baseline. But for all of these baselines, so this cognitive inspired algorithm outperforms the baselines. And we make the most performance gains in the low mainstream group. That's quite interesting. We wanted to dive into that a little bit more. So we compared the predictive capability of this approach called polar groups, and as we anticipated, so we make the most performance gains for the low mainstream group. And if you remember, so they are not really similar to each other, and we assume that they have a more individualistic listening behavior. So recommending them items from their own listening history that they have used frequently and recently seems a really good choice for these users in an offline study, I should say. Of course, recommending genres is one thing. Yeah? This is really broad, even if you have 2,000 genres. So we did the same experiment then on recommending artists. For that, we had to modify the data set a little bit more because we had to map genres and artists together. And we used this so in this last.fm, so users can assign tags to tracks or to artists, and then we map these user-generated tags to the genres in this free-based taxonomy. So this is then the relative frequency of a tag assigned to this artist. There are some tags in, of course, that needs to be removed. So, for instance, one of the most used tag in this taxonomy in last.fm is now listening. Of course, this does not convey any kind of music-related information, so we just had to remove some of them. And we also removed tags that had a relative frequency that was smaller than 0.5 in order to have like a manageable number of genres for an artist. So for instance, for Metallica, this gave us the tags thrash metal, metal, heavy metal. And if you think this is too specific for metal, for Metallica, then I have here the picture of normal people who say maybe this is metal, but then metalheads have like this kind of discrimination. And I mean, I have some of these metalheads in my group, so they are really particular about being very specific when it comes to metal music. Yeah, you can find this data set with artist information and also in the same scenario repository if you want to work with the data that we used for our studies. But we also then, in this experiment with artists, we worked with the full activation equation. So in the previous experiment with genre groups, we only took a part of this activation equation from ACT-R, so this BI. But it has also something that is called associative activation. And that tells us how important a memory unit is in the current context of a user. So, I don't know, you want to search for some literature, you're searching on a specific topic, you're working a paper on a specific topic, and then you would like to retrieve information that fits to this topic. So this would be one example. In the context of music, so you listen to an artist, and this artist is maybe part of a broader genre. So you want to stay in the same genre, so this could be your context. This full activation equation has two parameters. So it has an attentional weight. So how important, how much importance you would like to give that, and the strength of association. To show you how we use that in our experiments. So in our case, like I said, so the current context would be then the genre that the user is currently consuming music in. And I mean, in our experiment, we set the attentional weight to 1 because we did not want to boost any kind of genres. So, but it could be, so this could also be set to like the most popular genre within a group or whatever. But we did it. We wanted to give equal weights to all our genres, context genres. And for the strength of association, we based on the work by Van Manen, we took as a proxy for the strength of association the normalized co-occurrence of the genres. And I'll explain maybe this equation in a little bit more detail. So C would be the context genre. So you're listening to music, and we take the last listen to artist and the genre that this artist has assigned as current context. And G would be the genres that are in the listening history of a user. And so we compute this overlap between the genres that the user has just recently consumed as well as the history in order to derive the strength of association. So this gives us like a tuning mechanism to further personalize or to further contextualize the approach. You put here the precision and recall plots for this experiment, and you can see that when you put in the activation, the associative activation, or when you factor that in, then the approach is even further improved because it helps with contextualizing even further, personalizing even further. And this is true for all user groups. But as you also can see from the scale, so we make the most improvements again for the low mainstream user group, which kind of is also a hint of this very individualistic behavior that this user group seems to have. Then there's another issue. So why is this interesting at all local mainstream consumers? One could also think of, right? Okay, those are like this elite, these niche people. They don't contribute so much to the platforms. They have their specific interests, so we should more focus on the people who like the mainstream. Let's see. One problem why these users are interested in this problem of popularity bias. And I think we have heard about popularity bias and biases in the RecSys conference in the past days quite a bit. One issue of popularity bias is that users who like non-popular items, they receive less relevant recommendations. But I think this is also very problematic from the artist perspective, because there are, of course, rich get richer effects. There's like less exposure for less popular artists. 2 minutes? No? Ah, okay, great. And also problematic from the system perspective. And this is, of course, not only true in music recommender systems, but in all kinds of recommender systems where you have a long tail distribution. So I will just go over quickly, because we dove into this problem in a paper that was presented at ESU last year. This was a reproducibility paper of a paper by Himan and Robin and Masoud, who showed the problem of popularity bias in movies, and we could reproduce. We made the same findings as them. And interestingly, so these low mainstream consumers, they produce a lot of data because so they are not the ones in the long tail. They are the ones who have a rich user profile size. So it would be nice to have to support them much better. So we found that many algorithms have popularity bias. So this is kind of one of the issues that they have. And I mean, we've seen this from the experiments in our human memories here. So we seem to, with this simple approach, we seem to have more accurate recommendations for mainstream consumers. So human memory theory helps us improve user models for music consumers overall, but in particular for these non-mainstream listeners. So they seem to capture this individualistic listening behavior better. So familiarity, mere exposure seems to be more relevant for this type of user groups. A nice side effect of this approach is it has a very transparent model. It's based on a solid evaluated theory. It's computationally not extensive. But as a future work, I would say, so we need to understand the decision-making behavior of those non-mainstream users much better, because we looked at the user group themselves in a paper that is currently under review, and we found quite some differences within the group. So they seem to be even more individualistic within the group. But they produce lots of interactions data for the systems. So I think there are lots of future work could go to see that we gain a more deep understanding. So one assumption could also be like they are so individualistic that the recommender system would disturb them. So they don't want to have social influence at all. But this is just a hypothesis. I want to thank my collaborators in this set of experiments. So it's like Dominik and Peter from my group, Christina, who is now in Utrecht, Eva Zangerle from Innsbruck, and Markus Schädel, who provides this great data sets and is also a great collaborator of mine. With that, I would like to thank you. I'm happy to answer questions. Please get in touch if you have questions, ideas, research collaborations. I would be happy. There's lots to do. Thank you.
So thank you, Elisabeth. Thank you very much for this very interesting presentation. So we still have some, let's say, 4 minutes for discussions. So I directly hand over to the audience. So if you have questions, we can start with that. Okay, so if there are no questions, I can start. I hope you hear me, Elisabeth.
Yeah, sure.
Okay. So one question I had at the conference yesterday, and there was this discussion. So I also ask you, how would you differentiate between mood and emotions? Because in most of the work I know in recommender systems that are related to music recommendation, we are talking about emotions. So what's the mood context? Is there a difference? I do not see the concept of mood quite often exploited in the recommendation context, but maybe I'm wrong.
Yeah, I mean, so the way I know mood in the context of RecSys is it's the mood regulation. Yeah. So you are in a bad mood, and you want to get uplifted or something along these lines. Yeah. And I'm honestly also not completely sure about the differences between mood and emotion, but emotion seems to be something, to me at least, that is a little bit more stable. It's not like personality, but it's something that maybe for longer, or that may be more characteristic. But a mood is something, from my point of view, that's really in the situation. It's very much situation dependent, and an emotion might be something that dwells for a longer period of time. But maybe this is a question for Marco.
Okay. Further questions from the audience? Yeah.
Sorry about this. You see me, guys?
Yeah.
Yes.
Elizabeth, thanks for a really nice talk. I spent 2 years with John Anderson working on Ektar. And then hasn't been using it. It's exciting to see it's being applied to recommender systems research. So, but there's been a range of developments in cognitive architecture field, and Ektar is a great thing now that, but it's an old theory to some extent. Is there anything else new in the area of cognitive modeling which might be an alternative way of helping us in recommender systems? Because John Anderson himself, after I already left and went to the University of Pittsburgh, there's a lot of work on connecting neural neural architectures to cognitive architectures. So the group progressed quite a lot, and it looks like you're still looking at Ektar as it was at its heydays.
Mm-hmm.
So,
true, yeah. It means that one of the reasons why we're looking at Ektar is because of its simplicity and its high transparency in the elected mode. Because it is one of the main advantages, I would say, in contrast to a connectionist approach. I mean, depending on how many layers you have, but true, yeah. So we probably would get more accurate results, but so it means that it's no mainstream consumer. They're really not well understood. Yeah? So we really need to have transparency in the way we study them. This is one plus side, I would say, from this Ektar theory. But I know Anderson, of course, said himself, so he designed it in order to understand cognition, but he was left with more questions than before. But yeah, there's lots of work on connectionist approaches that are, of course, worth checking out. Yeah. In this respect.
Thank you. Yeah, I really hope that will be more work. It's really exciting that your keynote opens us this new direction of exploration.
Yeah, I completely agree. And I mean, I think lots of psychologists are now really up for it because they have this kind of tool, especially the computational cognitive modelers. They have this kind of tool sets already to work with us.
Thank you. Well, as a chair of the next session, I probably just need to remind that we need to switch.
Yeah. So thank you very much again, Elisabeth, and I hand over to Peter. Yeah.
All right. So good morning, everybody. We have a busy program, but so far you only have two things before the break, and there are two papers. The first one is end-to-end learning, conversation recommendation. A long way to go. I hope we will figure out is a long way to go or not. And it looks like Ashta Manzoor will be presenting. Welcome, Manzoor. The first time for you for this work at the workshop, right?
Thank you. Yeah. So let me share my screen first.
And the co-author is Dietmar Jane. I'm not sure Dietmar is at the workshop, but he is surely at the conference. So you can still ask him questions as well later.
Yeah. So can you please see my screen?
Yep, looks good.
Okay, cool. So thank you for the introduction, and this research is contributed by Dietmar Jane and me at Shah Manzoor. So let's advancements in technology. So basically, recommender systems are among the most visible success stories of artificial intelligence in practice. However, major advances were made in the area of language technology, and we are nowadays able to issuing voice commands to our home assistants and smartphones. So these developments led to an increased interest in the area of voice assistants as well, and we have observed a fast uptake of chatbot technology in recent years. Chatbots, both simple and sophisticated ones, are able to process natural language and are nowadays widely used in application domains, for example, to deal with customer service requests. Having said that, all these technological advancements led to an increased interest in conversational recommender systems research during the last few years. So, conversational recommender systems, abbreviated as CRS, background and contribution. Basically, conversational recommender systems can be developed in using different technical approaches that are available in the literature. And end-to-end learning conversational recommender systems research, the whole recommendation process is basically based on machine learning and deep learning models, and these models are trained with the example conversations. So in the development of CRS, there are two major computational tasks. The first one is to generate next utterance based on the dialogue history up to that point. And the second one is to compute and provide recommendations based on the user preferences. So although recommender systems can be evaluated in various dimensions using different methodological approaches, however, in end-to-end learning CRS approach, mainly the evaluation approaches revolves around these two components, that is to measure the quality of the generated utterances and the quality of the made recommendations. So in this research, our whole contribution is based on is based on the evaluation of two state-of-the-art conversational recommender systems. So motivation and goal. This is quite interesting to know that how we started and proceeded with this research. So looking at the hand selected example conversations in the supplementary material of one of the selected system, we found a number of sentences that were not meaningful. And secondly, on manual inspection of these generated utterances, we found all utterances identical with the utterances in the training data. So the goal of our overall the goal of our research is to quantify the extent of these problems. So the title of first selected paper is Towards Deep Conversational Recommendations, called Deep CRS. In their original evaluation, first they measured the recommendation quality as a measure of root mean square error score compared with a baseline system called HRAT. Secondly, they conducted a subjective assessments with real users, that is 10 participants. And the task of the participants is to rank the utterance of the deep CRS compared with the utterances by the human recommenders and utterances generated by the HRAT system. So in this picture, we can see that deep CRS sentences, more number of deep CRS sentences achieved 1 and 2nd rank, and less number of deep CRS sentences received 3rd ranking as compared to the HRAT system. So overall, this study shows that deep CRS model performed better than HRAT. So the second paper that we selected is titled as Towards Knowledge-Based Recommended Dialogue System, called KBRD. So in their original evaluation, first they measured the perplexity and distinct n-gram to measure the fluency and diversity of the natural language. Secondly, they measured the recommendation quality as a measure of recall compared with the deep CRS system that we discussed previously. So thirdly, they conducted a subjective assessment study with 10 participants in which the participants were supposed to assess the consistency of the utterances with respect to the dialogue history compared with the utterances of deep CRS. So in this particular study, the results show that average consistency score for KBRD was 15% higher than deep CRS. So here comes our part. We actually conducted a few analysis on these systems, and first we reproduced these systems on our local environment, and we generated 70 dialogues from the test data set by a random selection. So the first analysis is novelty of system generated utterances. This is an automatic analysis in which the goal is to know how different are the system generated responses from the training data, because the KBRD authors measured perplexity and distinct n-gram. So specifically, the task of this analysis is to know what fraction of system generated responses is identical or almost identical with the utterances in the training data. So sorry, my slides are not moving. So this is the, sorry for the disturbance. This is the results of this analysis, and we see that deep CRS generated 399 sentences and KBRD generated 359 sentences overall. 46 unique 46 deep CRS sentences comprised of 70 dialogues, and this number goes to 159 for KBRD. So this is quite interesting to know that deep CRS generate no new sentences in 70 dialogues, and this number is quite low for KBRD, that is 5. So looking at the data table, it resembles more like a retrieval approach rather a language generation approach. And interestingly, the measuring the linguistic properties, for example, perplexity, is not that much meaningful, because perplexity is eventually measuring the perplexity of the data in the training data. So the second analysis is the quality analysis of generated utterances. This is a subjective assessment in which the goal is to know how meaningful are system generated responses in the given context, because the original evaluation approaches were based on relative ranking exercises. So specifically, the task of human annotators were to label each generated utterance as meaningful or meaningless in the given dialogue context. Procedure. The procedure is simply to assign label 1 in case of meaningful utterance, and otherwise 0 in case of meaningless utterance. So in total, we had 3 participants, 2 two of them independent evaluators evaluate each system, that is KBRD and Deep CRS. And to obtain the second opinion, one of the authors evaluated both systems. So in short, we had two opinions for each system, and generally the agreement between participants was very high, that it was 92%. So third analysis, the data of the analysis method is, in case of Deep CRS, only 69% responses were considered as meaningful, and this number even goes down by KBRD, that is 58%. So overall, on the average, about 35% of generated responses were not considered meaningful. And interestingly, there are only 5 dialogues out of 70 in which there was no issue as identified by the annotators. And thirdly, out of these 279 meaningful sentences in case of Deep CRS, 85% of sentences were categorized as meaningful chit-chat sentences, and this number goes to 87% in case of KBRD. So both systems performed better in generating chit-chat sentences than the rest of the type of sentences. Third analysis is about quality analysis of recommendations, in which the goal is to measure the quality of made recommendations, because the original evaluation approaches were based on statistical measures like RMSE and recall scores without human assessments. Specifically, the task was to judge the quality of the made recommendations in the given dialogue context. So procedure is exactly the same as we had in the previous study, except here the participants were supposed to judge the quality of made recommendations. So here are the results. Deep CRS generated in total 106 recommendations, and this number goes to KBRD. This number goes to 119 in case of KBRD. So 60% of recommendations were considered as meaningful in case of Deep CRS, and this number even drops to 55%. So the subjective performance of KBRD was lower than the Deep CRS, even though surprisingly, KBRD included one knowledge graph of entities in the movie data domain called DBpedia. And the perceived recommendation quality for both Deep CRS and KBRD is even less than 2/3 of the total made recommendations. So the question here is if such a failure rate is actually acceptable in practical application domains. Important findings and implications. In our 70 examined dialogues, we found 9 cases to be broken. So this is an open research question. That is, what is the impact of noise in the training data on the performance of an end-to-end learning system? And moreover, the current evaluation approaches seems to be not that much informative in terms of practical usefulness of such system, because relying on the subjective assessment comparisons does not tell us whether or not the better rank system is actually good. And interestingly, the linguistic aspects like perplexity mainly judge the perplexity of these statements by humans. Finally, based on this research, we formulated a hypothesis and as a future direction, that is, maybe a retrieval-based approach might achieve the same performance or even better. Thank you.
Thanks very much, Manzoor. We have a little bit time for questions, 2 minutes. So hopefully the next speaker will be ready. Questions, please. 1, 2, 3. Okay, I have a question. So I was hoping they can ask that. So it's actually a very interesting example of how automatic versus regular evaluation might bring considerably different results. So what do you think is the threshold of where we can consider evaluations as kind of, well, recommendation as useful? So like 60% of them are meaningful, but maybe it is good, right? And then the second part of the question, but the knowledge graph is good for explanations. And in your case, there was no explanation. So as a result, knowledge graph-based system might look inferior, right? But in fact, would you adding explanation might be looking better? So there are 2 parts.
These are both quite interesting questions. First, to respond to the first part, The first part was, can you just repeat the
60,
first
yes. So you say 60% of meaningful things.
Ah,
You say
yeah.
it's kind of bad, but maybe actually good. 60% of recommendations are meaningful. Oh my God. What do you think?
Yeah, that was quite surprising for us as well, because once we observed the data analysis of the participants, we found that many of the recommendations were repetitions in the same dialogue, and in some cases there are the same recommendation was made as the seeker mentioned movie as a preference. So these are the red flags that we found, that these recommendations are, you know, like not meaningful in the real domain, if we think like that. So
Right.
secondly, can you just repeat the second question?
Right. So I need to remember my question.
DBpedia, you talked about
Right.
DBpedia.
Yeah. Explanations. Yeah.
Yeah.
The point is that it looks like knowledge graph approach was inferior a little bit, right? But the real
Basically,
strength of this approach is transparency and explainability, which you haven't measured. Maybe this is the.
this is quite interesting. We've measured it actually, and you can, if you see our manuscript that we submitted, you will find out that we are actually categorized these 70 dialogues into intents as well, and explanation is one of our intents. And we mentioned that in most of the cases, the explanations were marked in most of the cases, explanation utterances were marked as meaningless, because these explanations were not actually according to that particular movie, but it was general something, you know, like it's pretty good movie, or maybe in a wrong explanation. And basically KBRD, when we looked at the KBRD system, we found that KBRD actually make use of the metadata in the context of understanding genres like fantasy movies, crime type movies, horror movies, something like. They also incorporate DBpedia into that context as well. So so that's why it was basically it was a very you know, like very torturing process for us, because the KBRD author actually updated their code base for 3 times, and we did these studies 3 times, 1-to-1. Like first we conducted a study, we update the author that these are the results. He said no, sorry, these are the mistakes in my code. So he did that things and he solved that. Then we did again, reproduce the system, did these things. Like these were the 3 iterations, and this is the results of the 3rd iteration. So that was actually a cumbersome process for us, but eventually the results are even not better, you know. So that was the whole goal, that these are the, like, and in their original valuations, you know, like there is no subjective study that judges the quality of the made recommendations in general. So that was the points that we try to highlight in the current systems.
Okay, yeah, thanks. I wish we can get a better discussion longer, but we need to switch for the next paper. Thank you very much again for the presentation. So the next paper, hopefully the author is ready, has a long list of authors, and it's entity recognition for conversational recommender systems. So I think Andrea is going to present it. I might be wrong. Yes.
Okay, one moment, please.
All right, there's a long list of authors. You will see that on the front page of the slides, I hope.
Okay, can you see my slides?
Yep. All right.
Okay. Okay, hello. I'm Andrea Iovine, a PhD student from the University of Bari in Italy, and today I will present our work titled A Comparison of Services for Intent and Entity Recognition for Conversational Recommender Systems. A conversational recommender system is defined as a system that provides recommendations to users via a dialogue. The user profile is acquired interactively, and in fact, users can influence the outcome of the recommendation by providing feedback on the suggested items. This feedback is incorporated into the system and used to improve the next recommendations. Meanwhile, conversational agents such as Amazon Alexa and Google Assistant have reached widespread usage thanks to recent advancements in natural language processing. Due to their conversational nature, they are often used as an interface for conversational recommender systems.
However, developing a chat-based interface for a conversation recommender system is a very challenging task, since it requires multidisciplinary skills, which range from natural language processing to machine learning and human-computer interaction. In particular, understanding messages written by users in the conversation recommendation scenario is hard. This is because people can express the same concept in many different ways. So, for example, if someone wants to find a restaurant, they may ask something like, "Can you suggest me a restaurant?" Or they can simply say something like, "I'm hungry." Entities may be referred to with multiple surface forms. So, for example, Barry Eugene Carter, who is more commonly known as Barry White. Ambiguities are also very often present with natural language. So, if someone says something like, "I like Harry Potter," the system should understand if they are referring to the entire series or rather to a specific book in the series. Many chatbot development platforms are now available on the market. They offer many of the tools that are required to develop and test conversational agents quickly, and with commercial and open source options are available. So, are they suitable for the conversational recommendation task? That is, can they handle the variability and ambiguity of messages written by real users? The focus here is on the natural language understanding components that are offered by these platforms, and in particular, to the intent and entity recognition tasks. The objective of this study is to answer the following questions. The first is a purpose-built solution better than a general-purpose one for a chat-based conversation recommender system? Of course, developing custom components is more expensive than using off-the-shelf ones, and we need to be sure that the cost is justified by an increase in performance. The second question is, does fuzzy matching improve entity recognition performance? So fuzzy matching enables systems to recognize words even if they are not spelled correctly or completely. While the advantages may be obvious, fuzzy matching may also have some drawbacks, for example, by introducing more noise in the recognition process. The third question is a commercial intent recognizer better than an open source one for a chat-based conversation recommender system? So this is a possible architecture of a generic chat-based conversation recommender system. So we can see that the user's message is sent to a natural language understanding component, to a dialogue text tracker, a dialogue policy component, the recommender system itself, and a natural language generator component, which then produce the response to the user. So the user message is first analyzed by the natural language understanding component. This component is responsible for extracting all information that is contained within the user's message. So two tasks are commonly associated with the natural language understanding, which are intent recognition and entity recognition and linking. Intent recognition is performed to understand the general action or request that is formulated within the message. So, for example, writing "I like Braveheart and Mel Gibson" indicates that the user is providing some ratings to the system. While, for example, asking "What movie should I watch tonight" is an indication of the user's intention to receive recommendations from the system. Entity recognition is used to extract named entities that are mentioned by the user. So, for example, a conversation recommender system that suggests movies should be able to recognize entities such as movies, actors, directors, and genres, and should be also able to match them to actual entities within a knowledge base. So, for example, when the user writes, "I love Jim Carrey, but I don't like Yes Man," the system should recognize both a positive rating to the actor Jim Carrey and a negative rating to the movie Yes Man. The dialog state tracker is responsible for maintaining the state of the conversation between the user and the system, and the dialog policy component instead selects the most appropriate action to perform based on the dialog state and the current user message. Finally, a natural language generator is in charge of generating a text feedback that will be returned to the user. To model the interaction between the user and the system in this experiment, we devised a very general dialog model which involves only 3 distinct actions, which are providing a preference to the system, requesting a recommendation, and inspecting the user's own profile. So we chose these 3 actions as they represent the most basic activities that can be performed by a conversation recommender system. So acquiring the user profile, requesting generated recommendations, and viewing the profile. Also, this has the advantage of being independent from the actual recommendation algorithm that it's used. So, in this experiment, we included several commercial platforms. One of these is Dialogflow, which is developed by Google. It offers a web-based interface for developing the dialog model and supports multiple languages and can be easily integrated onto several messaging platforms. So the Dialogflow offers both intent and entity recognition functionalities, and in particular offers fuzzy matching for entity recognition. Watson Assistant is a platform developed by IBM, which offers a set of functionalities that is very similar to Dialogflows. So even in this case, we have both intent and entity recognition functionalities. We also included the LUIS platform, which is developed by Microsoft. It offers a wide range of natural language understanding functions and can be easily integrated with other services in the Azure platform. However, unlike Dialogflow and Watson Assistant, the entity recognition component offered by LUIS does not feature fuzzy matching. Then we included also RASA, which is an open source on-premises platform for conversational agent development. It is highly customizable and also offers advanced machine learning approaches for dialogue management. The natural language understanding module of RASA can do both intent and entity recognition, but no fuzzy matching is available by default. We also included in the experiment some components that were built in-house. NER FCR uses a combination of 2 approaches to perform entity recognition, which are conditional random fields and regular expressions. Fuzzy matching is then used to link the entity mentions with entities that are contained into a knowledge base. So the advantage of this approach is that it can recognize entities even when they're not spelled correctly or when they're spelled incompletely. This component was developed using the Stanford Core NLP library. The second custom-built entity recognition component is NER-KG, which instead uses a knowledge-based approach. It works in 2 steps. During the spotting step, the algorithm discovers sequences of words that match a Wikidata alias. During the linking step, it uses an approach that is based on graph embeddings to select the correct concepts for each entity mention that was discovered during the spotting step. Unlike other entity recognition components, this one does not need any training data to function. So to answer the research questions of this study, we compared the previously mentioned platform based on their ability to understand messages written by real users in the conversational recommendation scenario. In particular, we focused on the intent and entity recognition tasks. The experiment was performed on a dataset that was created by logging interactions between users and an existing conversational recommender system. The dataset contains messages from 3 domains: movies, music, and books. The dataset contains also 3 intents and 3 entity types for each domain. So the intents are the ones that we have seen previously for the dialog model, which are giving preferences, requesting recommendation, and reviewing the profile. And for the entity types, we have items, which are movies, songs, and books, people, such as actors, directors, artists, and so on, and genres. So for the test, we trained and tested each platform for each domain using 5-fold cross-validation. We then calculated precision, recall, and F1 metrics for each domain and also overall domains. So these are the results of the intent recognition test. The results show that all platforms performed well for this task, achieving an F1 score that is higher than 0.99. So Watson Assistant, Lewis, and Rasa managed to achieve comparable results, while Dialogflow instead is in last place. For the entity recognition task, the best 2 systems are NER FCR and Dialogflow, followed by Watson Assistant, NER KG, and in the last 2 places we find Lewis and Rasa. This can be explained by the fact that these last 2 lack the fuzzy matching component, as we said earlier. So we performed some statistical tests which confirm that the differences in F1 between the various platforms are statistically significant. And this is true both for the intent and the entity recognition tests. Also, they can confirm that Dialogflow performs significantly worse than the other platforms in terms of intent recognition. However, they were unable to find a platform that performs significantly better than all the others. For the entity recognition task, the test confirms that both Dialogflow and NER FCR have significantly better F1 compared to all other platforms. The difference, however, between the two are not significant. Another interesting result is that all entity recognition tools that support fuzzy matching are significantly better than those that do not support it. So, to answer the research question 1, we can say that a custom-made solution is not necessarily better than a general-purpose one. In fact, we have seen that Dialogflow entity recognition component was able to perform comparably well to custom solutions. This is interesting because developing a custom component is indeed more expensive, but this does not cause an increase in performance. For research question 2, we can say that fuzzy matching is indeed helpful in recognizing noisy identity mentions, and this is able to overcome the potential drawback of using this technique. So to answer research question 3, we can say that no, commercial intent recognition software is not better than open source components. As we have seen, Rasa managed to perform as well as the commercial platforms. So for future work, we plan to extend the experiment by introducing new domains, new intents, and by increasing the variability and complexity of users' message. Finally, we will increase the number of platforms that are included in the experiment. So thank you for your attention.
Thank you very much for the talk. We have about 8 minutes for questions. You can ask your questions in the Hover platform in the question answers, or just be brave and speak. So any questions? All right, so this is the job of the chair to ask the question. I'm doing this job for the second time. So Andrea, it's a really interesting results. The question in comparison with the first talk is how much better is enough to be really good? So we can show that one system is significantly better than the other, yet is it good enough from the user prospect? Could you offer some potential hints on that? I know that is pretty much data-driven evaluation, but what is your feeling as an expert in this conversation recommender system? The level which has been achieved by your best two performers, is it good enough for users to be satisfied?
Okay, in terms of intent recognition, we can see that we can achieve performances that are at 0.99 of F1, which means that there's very little room for errors in at least recognizing what the user is trying to do. Of course, when recognizing entities, which is also important because our recommender system should be able to understand which ratings or which movies a person likes, we still can achieve relatively good performance. We still have in the range of 0.9. Yes, we are, the worst results are like 0.84, which is still pretty good as a result, and shows that, yes, we can actually use this for a real product if we want to.
Yeah, definitely. So again, the question is to what extent it was looking good and meaningful for the users, because entity recognition is an important thing, but there are a bunch of other issues in the holistic user experience. So as we're trying to push up already reasonably good entity recognition part to even better, to 0.99, which is really amazing, should we really invest in that part? So you use focusing on these two parts, recognition of entities and the recognition of intentions, like two critical sides. Is there two really most critical for the user in conversation recommender? Is it what getting them frustrated? Is there any research evidence which is backing up the focus of your original research?
Okay, yeah, I understand the question. I can see that we, in our research group, we have performed several tests with users with regarding conversation recommender systems, and one of the most frequent causes of user frustration was really making the system understand what the user was talking about. So oftentimes users would just say, why this system couldn't understand the fact they talk about this movie, or why didn't it recognize this name. So we can say that this is something that users really care about, and they really get frustrated when the system doesn't understand.
Thank you, Andrew. That's exactly what I wanted to check. Did you publish this interesting results? That might really help future researchers who is doing the same direction of work. So there's a fraction of users who are getting frustrated, how frequently that happens, because we really need to know what to focus on in this domain.
Well, this was more of a side effect of an experiment that we were actually conducting. So we didn't publish a paper exactly on this this issue, but we mentioned it in the papers in which we described these experiments.
Okay, thank you. There is a chance for one more short question before we go for a break. Well, I don't see questions in Hua, and I don't have anyone else asking question except my phone is ringing. Maybe somebody calls me by phone to ask a question. Anyway, thank you very much, Andrei, again for the talk. Now we are departing for 1 hour long break. Have your lunch, have your dinner, have your breakfast, and we'll meet together in 1 hour.
So I hope you can see my presentation.
Yes.
Okay. Hello, everyone, and thank you for attending my virtual presentation today. My name is Siddha Naveed, and I'm a PhD student in Interactive Systems Research Group at University of Duisburg-Essen, Germany. This presentation aims to present an interactive hybrid approach that combines advanced explanations with interactive mechanisms with the purpose to improve the user-oriented aspects. So recommender systems based on collaborative filtering or content-based approaches mainly focus on improving the accuracy of predictions. And it has been argued that the most accurate systems may not be those that provide most useful recommendations, and users need more than just accurate recommendations to fully benefit from the system. And studies have shown that improving these user-oriented aspects leads to a commensurate level of user satisfaction and improve the overall system effectiveness. One of these aspects is the degree of control users have over the recommendations and their preference profiles. And in many real-world systems, users have limited or no means to influence the results or update their preferences, which is mostly in terms of rating or re-rating single items like in Amazon, or thumbs up and thumbs down option in Netflix. And in such cases, changing or updating the feedback or preferences are sometimes not immediately reflected in the results. And additionally, users do not understand the effect of their control actions on their recommendations and their preference profiles because the rationale behind the updated results is not explained to the users. Another aspect is the explainability of recommendations. And many approaches have already been proposed to provide explanations mainly based on collaborative filtering and content-based approaches like the one in Amazon or text explanations. And even though such conventional explanation styles can be considered effective in most standard recommendation scenarios, but in complex domains such as digital cameras, where the features of items play a vital role in users' decision-making, such simple explanations might not be sufficient for users. And the existing explanation approaches, which are mainly based on conventional collaborative filtering and content-based, does not explain the relevance of recommended items in terms of the user's preferences of item features. And additionally, again, the rationale behind the recommendations are not clearly explained to the user. And there are limited hybrid approaches that have already combined the benefits of collaborative filtering and content-based approaches, but with the purpose to improve the user-oriented aspects to some extent. And one of the exceptions is our previously proposed hybrid approach that exploits content features in a collaborative filtering with the purpose to provide advanced explanations, which we presented in Complex Recommender Workshop, RecSys 2019, and the extended work in Exam Workshop, UMAP 2020. So in the current work, we go beyond our previous approach and we specifically focus on addressing the following research question, that how integrating such hybrid explanation with interaction tools improve the user-oriented aspects compared to a conventional filtering system that also exploits content features. So here's the agenda of our next slides. First, we present our hypothesis, which is based on our research question. Then we briefly present the hybrid approach. Then we present our prototype, which we implemented on top of this approach. Then we present the results of our user study 1. And then we conducted a follow-up user study to further investigate the results of user study 1. And finally, conclusion and future work. So in line with our research question, we hypothesized that integrating the hybrid explanations with interaction tools when compared to conventional filtering system leads to more concrete preference elicitation, better explained recommendations, more comprehensible recommendations, more direct manipulation of user preferences, more controllable manipulation of preferences, and improved user experience. Where hypothesis 1 is basically associated with the aspect of preference elicitation, hypothesis 2A and 2B is associated with the aspect of explainable recommendations. Hypothesis 3A and 3B is with preference modification. And finally, we have an aspect of user experience. So here is a brief overview of the approach. Due to time limitation, the detail of the approach is not presented here, but you can find it in the paper. In the first step, the user items ratings metrics and the item feature metrics are exploited in an ordinal regression model that predicts the feature weightings for each user in our data set. And this process is done offline. In the cold start, we elicit the user's preferences with respect to features of items. Then these active users as well as other users' feature-based profiles are exploited by applying some similarity computations. Basically, this step computes similar users in terms of shared feature-based preferences. The system then generates item recommendations as well as their corresponding explanations based on these similar users' preferences. We then implemented a prototype system on top of this hybrid approach, which we call featuristic. And the prototype extends the conventional approaches in terms of three main user-oriented aspects. The first aspect is preference elicitation. So instead of just asking users to rate or redate items or just select feature values through filters like in conventional filtering approaches, in the featuristic, we elicit users' preferences by asking them to select feature values and select the importance of feature values using the importance slider. Additionally, in case of limited domain knowledge or undefined contextual needs, the system provides users with an option to indicate their preferences for one of the 5 most common photography styles. By selecting a mode, the system further provides users with feature set along with the suggested values, explaining why these features with certain values are important for a particular photography mode. The user can add the entire feature set into the filtering process or select specific features. Another aspect is explainable recommendations. In our prototype, we first explain the relevance of recommended items to the user's preferences for item features by showing a table that compares the features of each recommended item with the user's preferred features. The system further visually explains the rationale behind the recommendations in terms of similar users, shared feature preferences with the current user, explaining why the items are recommended. Furthermore, we mapped the recommended items on top of this feature distribution to further assist users in detecting relevant features and to inform their own decision by narrowing down the list of items based on the item features. So additionally, in case users are unaware of the contextual requirements, they can explore each item to see that for which photography style the camera is best suited for by clicking on this link. And this opens a pop-up showing the computed similarity suitability scores for all modes for the camera. And each bar could further be expanded to see how the suitability scores for modes are computed. Then the third aspect is the modification of preferences. We provided the interactivity and direct manipulation within an explanation by using sliders and toggle buttons, and modifying the preferences would dynamically update the recommendations, showing users a better understanding of their control action on the updated results. So to test our hypothesis, we conducted user study 1, where we compared our futuristic system with conventional filtering system. And then the follow-up user study is conducted to verify the results of our user study 1. So in both user studies, for each condition, we provided users with same task scenario. Then we elicit their preferences in terms of features. Based on that, the system generates recommendations and explanations. The participants were required to then explore the system and select camera or cameras that satisfy their preferences, and finally evaluate the system by answering series of questions. So for the aspects, we mostly use self-created items. The aspect of explainable recommendations is further measured in terms of two sub-aspects, that is explainability and comprehensibility. And the aspect of modification of preferences is measured in terms of two sub-aspects, that is direct manipulation and user control. So for the user study 1, a total of 55 prolific users were recruited, which is an online crowdsourced platform. For this study, we implemented a filtering system prototype to be compared with our futuristic system. In this system, users can simply select features through filters based on which the system provides a list of matched items, along with a simple explanation only showing the comparison of recommended items with the participant selected features and values. So we applied MANOVA analysis to test our hypothesis. The results showed significant differences in favor of futuristic in terms of preference elicitation, explainable recommendations, and direct manipulation of preferences, thus accepting the respective hypothesis. However, in terms of comprehensible recommendations, controllable manipulation of preferences, and user experience, the results were not significant, and thus we have to reject the respective hypothesis. The significant results here clearly show the positive impact of integrating hybrid explanations with interaction tools on these aspects. And this can also be reflected in participants' qualitative feedback, where they like specifying the importance of features, the graphical information, and the ability to adjust personalized preference. The insignificant differences might be explained due to the fact that two systems were quite different in terms of explanations and interactivity that they provide, and ways to modify their preferences. And how users perceive and understand these mechanisms might also depend on the individual's prior domain knowledge and cognitive abilities. As stated by one of the participants, that the information was easy for me to understand, but I could imagine that less technical people would find the graphics confusing. And this might explain the reason why the results were not significant with respect to these aspects. To further verify that the underlying algorithm does not have impacted the user's perception of the user-oriented aspects in the user study 1, we conducted a follow-up user study. And in this study, we basically isolated the effect of underlying algorithm by applying the same underlying hybrid approach, with only differences in terms of interactive and non-interactive explanations provided by the systems. And for that, we again recruited 37 prolific users. And for this study, we created a version of futuristic with non-interactive explanations. The only difference is that the user is not provided with the functionality to modify or critique their selection through graphical explanations. So in the follow-up study, we compared the futuristic systems version one with the interactive explanations and the other with the non-interactive explanations, and compared them with respect to these user-oriented aspects. And the result shows that even after isolating the underlying algorithm, the futuristic system with interactive explanations significantly improve the aspects of explainability, direct manipulation, and user control, thus verifying the results of our user study 1. On the other hand, the insignificant differences in terms of comprehensibility and user experience might be due to the fact that both systems provided same functionalities and level of explanations, and the only difference is with respect to interactive and non-interactive explanations. And this might explain the reason for both systems being perceived of equal quality. So to summarize, we showcase the possibility of generating hybrid explanations that exploit content features in a collaborative filtering approach. We then integrated these advanced explanations with interaction tools and compared them with conventional filtering system, that provides simple and non-interactive explanations. The results showed that our approach significantly improves the aspects of preference elicitation, explainability, and direct manipulation from the user perspective. And when we further investigated the results by isolating the type of underlying algorithm and only focusing on type of explanations, our futuristic system with interactive explanations again significantly improved the aspects of explainability, direct manipulation, and user control from the user's perspective. So this clearly shows a positive impact of integrating advanced explanations with interactive tools. And in future work, we want to simplify our system design because for some participants, it was rather complex to understand the information. Additionally, there could be other underlying factors that might have impacted the user's perception, which need further investigation. This includes users' cognitive abilities and prior domain knowledge. Thank you for listening.
So thank you very much for the presentation. Yeah, so it's time for questions now. I assume the audience has plenty of questions. Please ask.
There is one question in the quick Q&A section. I probably can read it. Is the futuristic UI intended for final users? If yes, don't you think that explanations provided in the way are too complex for a standard user?
It's not for a final user because it's still a prototype system. But as we recruited, most of our participants were prolific users, so they were not, they didn't have a technical background. So they were basically new users that were using the system for the very first time.
Oh.
And even for these users, they really appreciated these advanced explanations, and they really can understand what was happening as compared to the filtering system, where it was too simple for them to make a choice about a camera or any item.
I just wonder whether the chair has access to the questions. I can read. There is a second question in the question answering section. I can read it. The negative result that adding interactive explanations doesn't help overall user experience is pretty surprising. What do you think are implications for interactive research?
Yeah, as I stated in my last slides, that there could be several underlying factors that might have impacted how users perceive and understand the information. So we tried to investigate few of them, and we also tried to investigate the effect of underlying algorithms in our follow-up user study. But I think there could be more factors like users' cognitive abilities and users' prior domain knowledge. I think these two are the factors that might have impacted the way users perceive different versions of the system. And yes, for user experience, that could also be a reason that why we didn't get any significant results, because for some users, the filtering system might be easy and easy to use, but for the others might be futuristic system. But this is something that needs to be investigated in the future work, definitely.
Can I ask a follow-up to that?
Yes.
Yeah, thanks for answering. I'm curious, you're saying that variation in user cognitive ability or prior experience could have impacted. Do you know if the data has some, like, if you just look at the data, is there some substantial category of users that thought the experience was way better, and then some that thought it was way worse, or did everyone kind of think it was the same?
Yeah, we collected a qualitative feedback regarding these aspects, but they were quite mixed. When we look into the quantitative data, definitely there were not significant results in terms of user experience.
Sure.
But in terms of qualitative data, there were quite mixed responses, and it's really difficult for us to say, okay, this one performed better in terms of user experience, in terms of qualitative feedback. So it was rather mixed. For some users, some aspects of one system was more interesting. For others, the other aspect of the system was interesting. So it's kind of really difficult to say which one performed significantly better in terms of qualitative data.
Thanks.
Do you have already ideas on how you could improve your system to focus on low domain knowledge users?
Yeah, that's a very good question, actually. We have investigated this aspect to some extent in our earlier studies, where we basically tried to investigate different cognitive abilities of the user, but not per se the experience or prior domain knowledge of the user. But I think in the next or in the future work, we could definitely see, first identify that whether a particular user has some domain knowledge about the cameras or not, and accordingly we can basically determine some kind of patterns and see which kind of user wants to see which level of information. I think this is really important, because the way and the level of explanation you want to provide to the user needs to be personalized based on the level of cognitive abilities that user has or the domain knowledge that user has. So, yeah.
I have a follow-up question. We have, looks like a few more minutes. We're trying to tease out what is the difference between the types of users who appreciate that complex system and who might be confused or overwhelmed. It may be domain experience. I'm thinking about maybe the stake of the recommendation. So it's one thing to recommend a song which you're going to listen for the next 5 minutes. Another thing to recommend a movie. It's 2 hours of your time. Maybe the camera which will be with you, I don't know, 2 years. But how about, like, for example, job recommendation? That's something which is really high stake, and that is a very feature-based area. Mm. So where do you think is the border in that sense? Where you need to start applying this explanation correction?
We had the similar paper in Tara's workshop last year, where we compared a music domain with digital cameras domain with some prototypes. But even in the study results showed very mixed kind of results, where we were actually predicting that in camera domain, user would rely more on these advanced explanations to make their decisions, because this is rather a complex domain and the decision-making process is rather complex. And we were assuming that in the music domain, they wouldn't really care about the level of explanations you provide to them. But instead, we got kind of really different and surprising results. But I think, yes, domain is something definitely a factor where which could basically moderate how user wants to see different levels of explanations. But this is something we already evaluated and investigated to some extent, but didn't get results as we expected, of course. But yeah.
Thanks. Lots of work.
Can I further questions? Yeah.
Yeah. So
Martin?
No, maybe also just one comment. It's really interesting stuff. I think I do think that you might want to consider next time to get a few more participants, so that you're more likely that these effects are really as strong as they are, because right now you're sort of on the edge of finding interesting effects because your sample size is low, which might give you more extreme cases in here. And then also, especially if you're going to do the moderation by cognitive abilities or need for cognition or whatever, then you definitely need more. But I would really recommend that. One other question I had, so you measured all these concepts. Do you also know how well they correlated? So, for example, is it? I have to look back at your questionnaires, but to what extent can these factors explain each other?
Yeah, not particularly in this study, but yeah, definitely maybe in the next extended work, one could also look how these factors are correlated with one another, because if you look into the results of the follow-up user study, where we just presented interactive and non-interactive explanations, we clearly can see that we found similar results as of study 1, but mostly in terms of user control, preference modification, and yeah, basically these aspects. So definitely one could say, okay, the interactive and non-interactive explanations definitely have or somehow correlated with these aspects of preference modification to some extent. But quantitatively, yes, we definitely need to look into it further.
Okay. Looking forward to see that next study.
Yeah.
Okay, so again, many thanks for this very interesting presentation. We have to move to the next presentation, which is a paper written by Dorin Shmariyahu, Guy Shani, and Braha Shapira. So the title of the talk is Post-Hoc Explanations for Complex Model Recommendations Using Simple Methods. So it's your turn, please.
Hi, everybody. So I'm Guy, and I'll be presenting the work of my student Dorin, who's now, getting better from a nasty case of COVID virus. So she's getting better, and I'm giving the talk. So I'll be talking about post-hoc explanations for complex model recommendations using simple methods. So what is an explanation? An explanation is some information about why an item is recommended. So not the computation of the actual recommendation, but why is it being recommended? And the benefits can be many. It can help the user to filter recommendations, and it can increase trust. For example, in the case when the recommendation is not so successful, and then maybe the user can see what went wrong. Now, some recommendation algorithms are really easy to explain. For example, if you consider the classic neighborhood-based collaborative filtering, when you have something like, you have a neighborhood of users for the active user, and then you compute recommendations based on the things that those users have liked. And then you can explain it as something like, people like you also watched that movie that I'm recommending. And the same goes for item-item collaborative filtering, where you can say something like, people who watch a certain movie that you watched in the past also like that movie that I'm recommending to you. Another class of algorithms which are really easy to explain are content-based algorithms, where I can say something like, this movie that I'm recommending to you is quite similar to another movie that you've seen in the past. Maybe it has the same actor or the same genre or something like that. So these algorithms are very easy to explain, but on the other hand, they usually give less than great recommendations. Now, there's another class of algorithms which give better recommendations, which are typically built on top of some complex model like a neural network or matrix factorization, where you have nodes with relationships and weights and latent features and whatnot. And these typically do give good recommendations, but are quite difficult to explain to the normal user. So another interesting way of creating an explanation is known as a post-hoc explanation, where you have a recommender that you treat as a black box, and the recommender generates some recommendation. And then the explainer is just looking at the data and the recommendation and trying to figure out an explanation. So the explainer does not see the recommender. The recommender is being treated as a black box, and you don't really explain the process. So these explanations are not really transparent. Transparent is when you try to explain why the item was recommended. On the other hand, you could get an explanation of why an item is appropriate to the user, not why the actual mechanism decided to recommend that item, but why that item is relevant. And of course, we're not the first people to suggest post-hoc explanation. There's lots of work on that. So the main contribution in this paper is about using multiple explainers. So we're using a post-hoc scenario where you have multiple explainers, and these explainers are going to be the simple algorithms that I've shown you earlier, like collaborative filtering and content-based. And what we're going to do is that we're going to have a recommender that generates a recommendation, And all these explainers are going to look at the recommendation and the input data and try to come up with some score on how relevant is that particular recommendation for the user. And then we're going to get all those explanations with some score, and we're going to put them into some filtering mechanism, and then select one of those explanations and show that specific one to the user. So this is the main contribution, and I'm not going to go into technical details here. I'm going to talk about the user study that we did in order to evaluate this approach. So we did the user study in the movie recommendation application, and yes, I know that everybody works on movies, and maybe that's not the most interesting domain, but on the other hand, it's typically easy for people to look at a movie and say whether they like it or not, and look at an explanation for a movie and say whether that explanation makes sense. We asked the participants in the user study to evaluate the recommendation quality. So we told them nothing about the explanations. They didn't get any prior information about the explanations that are going to be shown. We just asked them to say how good are the recommendations, and we showed them recommendations with and without explanations. And the hypothesis here is that when you give recommendations with explanations, you would get better response from the users. We also try to evaluate the preferences over the possible explanations because we have many types of explanations. So we had about 200 participants, most of them students, but not all. We had also older participants and younger participants. Most of the participants were males, which is not great, of course. Okay, so the user study started like that. We first asked the user to provide us with 5 movies that they like, and this allowed us to create a user profile so that we can generate recommendations. So now we're computing the recommendations, given those 5 initial movies, and we use 2 models, BPR, which is a matrix factorization approach, and autoencoder, which is a deep learning approach. And they are both what you would call difficult to explain recommenders. In addition, we also had a popularity recommender, which is used as a baseline in order to generate sometimes not so great recommendations and get some diversity in the ratings of the recommended items. So the second step in the user study was to show to the user 3 movies and ask the user to give us their opinion about those recommendations. Are they good or not? Now, 2 of the recommended items here were generated by either the autoencoder or BPR, and 1 item was generated by the popularity recommender. And again, this is in order to get some diversity in the ratings that people are providing. For example, in this case, it's quite obvious that the Grand Budapest Hotel, that's probably the one generated by the popular, and these 2 are generated by the actual algorithm. Okay, so here they're rating recommendations without explanations. And now we're going to compute explanations, and we had 7 different methods for computing explanations. The first one is a simple popularity explanation, something like this movie is popular, so this is why I'm showing it to you. We had 2 different content-based methods. One of them is an item-item method, where I'm looking for the movie most similar in the user profile to the recommended movie. And then I'm looking for an actor that played in both movies or a genre or something like that. And the third option was a user item, content-based, where we looked in the user profile and looked for a director that was liked by that user or a specific actor. And if that actor played in the movie that I'm recommending, then this is a good explanation. We also had explanation based on the movie description, similarity in the descriptions. And then we had 2 collaborative filtering explanations. One of them is item-item. People who like this also like that. And the user-user. Users like you also liked that movie. And finally, we had 1 strawman explanation. This is a meaningless explanation with absolutely no information, saying something like, our system predicts that this movie is good for you, but it has nothing, no actual information in there. Okay, so at the third step in the user study, we showed to the user a recommended item, actually 3 recommended items and explanations, and we had 3 different displays. On the left, you can see that we have a button, and the user had to click that button in order to see the explanation. In the middle, you see what we call the explanation teaser, where we're giving the beginning of the explanation, and then the user has to click the read more in order to get the full explanation. And on the right, we just presented the entire explanation. And this is a between subject study, so each user got one of these options. Now, the results here were kind of surprising. So for the button, only 24% of the users clicked even once the button asking for an explanation. And for the teaser, it was even worse. Only 14% of the users even clicked one teaser, which means that the people didn't really look for an explanation and didn't really actively ask for an explanation, which was somewhat surprising for us. So explanations may help users, but they're not actively seeking them. We also had a 4th step. In this step, we showed a single movie and with multiple explanations. And we asked the participant to rate the explanation, not the movie, to say what they think about each of the presented explanations. Okay, so let's move on to the results. So these are results for the part where they had to rate the movies. So we can see here that the ratings for the autoencoder were in general better than the ratings for the matrix factorization, for the BPR method, and the rating for the popular recommendation were even worse. If we look at the aggregates, we can see that the ratings given the content-based methods were substantially higher than the ratings given the other method. Most specifically, the popularity explanation, saying something like, this movie is popular, that's why I'm giving it to you, actually caused the users to give a lower rating than with no explanation. And the same goes for the default explanation, saying, I'm just predicting it to you because it's a good match for you. And the collaborative filtering explanations were somewhere in between. So I think that the take-home message from this particular step is that people do rate movies differently when they're shown different explanations. So the explanations do influence the way that people rate the presented recommendation. These are results for the final step, where we've shown different types of explanations and asked people to rate the explanation, not a movie. And again, if we look at the aggregates, we can see here that item explanations got the highest rating. And actually the lowest rating was for the popularity explanation, which kind of makes sense. And for the content-based user, this was a surprising result for us, that people really didn't like this content-based explanation. And perhaps the reason is that these explanations tended to be really long, because we're comparing the recommended movie to all the user profile. And the user profile may have many things that are similar to that movie. It can have the same director, the same actor, the same genre. And then these explanations tend to be really long. And perhaps this is the reason that people really didn't like them. Another thing that is interesting here is the strawman explanation, which you can see on the bottom, which wasn't all that bad. It was actually substantially better than the popularity explanation and the content-based explanation. So this explanation that has no information in it, people actually said that they liked it or didn't hate it. We also had a post-study questionnaire. So I'll go over a few of the things that we saw there. So first, people said that they noticed the explanations, which is kind of weird considering that they didn't really click the button asking for explanations. So I think that this goes to show how much you can trust people when they answer your questionnaire, as opposed to what they really do in the application. Most people thought that the explanations were mostly appropriate, which is good. When we asked them which explanation they like the best, they like the best the content-based explanations and then the collaborative filtering ones. And the default explanation, which didn't get such bad scores, had the lowest acceptance, let's call it. We also asked them whether they would like to see those explanations in a real system, and most users said that they would, which is also good. We also asked the participants about specific properties of an explanation. So on the left, you can see that people thought that it's really important for the explanation to be easy to understand, which is, I think, natural. But here there's something less natural. We asked the users how important is it for them that the explanation fully explains the mechanism behind the recommendation. And people didn't think that it was all that important. And again, this is what is known as transparency. So at least the participants in our user study didn't really think that transparency is all that important, which was kind of surprising for us. But good, at least for our perspective, that suggest post hoc explanations which have no transparency. Users, of course, thought that the explanation should be accurate and convincing and short. So people thought that it's very important for the explanation to be short, which goes back to the lengthy content-based explanation that people really didn't like. Okay, so to conclude, we suggest a very simple method for generating post hoc explanations using a set of simple recommendation algorithms. And we show that presenting post hoc explanation does influence the behavior of users. In general, we got higher ratings when an explanation was presented. We also shown that users prefer short explanations to transparent one, and that the explanation length and complexity do influence the effect that this explanation has over the user. So in the future, we would like to evaluate on some additional domains. Of course, movies is not enough. Maybe there's something, I don't know, particular about movies. We would like to apply some additional simple methods for generating those explanations. One phase that is done really ad hoc right now is the part where we filter out the explanations given the scores, and we should do something smarter there. And finally, we would like to learn user preferences about which explanation they prefer given all those available explanations. That's it, and thank you.
So thank you very much. Questions, please.
Can I ask a question?
Sure.
I was wondering if you have any idea of why people would click the button to get an explanation. Do you know anything about the intent that people have when they click this explanation button?
So first, as I said, they don't click the explanation, right?
Yeah, but the people who do.
So no, actually didn't really think to capture that because we thought that most people would click it. So it was kind of a surprising result for us. We originally thought that when you allow people to have more information about why a specific item was shown, then they would take it, but they didn't. So I don't have any good insights on the people who do click it. I thought that it was natural that people will click it, but obviously I was wrong.
Was there a correlation between like the rating that people gave and whether they clicked the button?
Yes, so there's just not enough data, right? Because only 14% of them clicked on them. But yes, there is some correlation between that and the popular movie, right? We've shown 1/3 of the recommendations were supposed to be bad because they were generated by the popular algorithm. So maybe those are this, but there's just not enough data given the amount of users.
Okay, thank you.
Just a comment. I think that this is also completely domain dependent, right? So if you have more high involvement items, cameras, or things like that, I think the situation could be completely different here.
Yes, it might be that if you have something that really requires people to think about the recommendation and decide whether it's good for them or not, then maybe explanations would come. But again, explanations is about, it's not about the item that has been recommended, it's about why this item is appropriate for you. But yes, maybe. I really think that we should try with different domains.
Okay, further questions?
Yeah, I posted some in the session Q&A, but I can also just directly ask them.
Good, because I can't.
Very nice paper. So it's when you're looking at whether people like the explanation or what they want from explanations, you said they don't need to have the mechanism explained fully, but they do want them to be accurate. How can we reconcile that?
So the accuracy is about whether the explanation fits the data, right? So if I'm telling you that here that this movie has a similar description to Iron Man that you like, in this example, right? Is that accurate? Is it really a similar description? If it is, then it's accurate, right? It doesn't have to be about how the algorithm is working. It has to be about whether, you know, really 22% of the users who like the same movies that you like also like this movie. So this is accuracy in my mind.
Yeah. Okay. Yeah, that's true. Although it would not always be easy to see whether the explanation is accurate, of course. But yeah, I had one other question. If you come, so in that second part, exactly this what you have on the slide right now here. You basically looked at the overall results of which explanation was liked more, but there were quite some differences between the autoencoder and the matrix factorization. Did you look at those differences, or did you not have enough data there?
No, so this is the place where you look at the different recommendations from the autoencoder. And yes, there are differences. First, in general, the autoencoder gave better recommendations.
No, I meant, no, sorry, I meant the explanation. So the next one. So for step 4.
So here I don't think it's not about the actual item, it's about the explanation. So I don't think that here it's important whether it was generated by the autoencoder or the BPR, but we did generate using both of them, but we didn't check whether people give different ratings to an explanation given the algorithm. So we didn't
can you show the table again?
This is about the rate. This is about phase 2. The
no, the next table of the other study that you see. I think.
Okay. Yes. This one.
No, first. Yeah, that one. Yeah.
Okay.
So the numbers are quite different in several cases.
Right. And I think that the numbers here are more similar because overall the ratings are more similar. As you can see.
Yeah, okay, maybe.
I can't really have any, you know, anything interesting to say. Yes, things are slightly different, but all the differences are kind of small, right? Like the lowest is 3 and the highest is 4. So people didn't say about any of the explanations, even the popularity explanation, that it's really bad, and they didn't say about any of the explanations that it's really, really great, like 5.
No, but I mean that basically the first 2 columns are somewhat different than the matrix.
I agree. I don't have any good explanation on why this column is different than that column.
No, it would be hard to explain perhaps, but although it might be that a particular algorithm might be easier to explain in a particular way, that people feel it's more accurate for a particular algorithm. That could be, but you probably won't have enough data to show that, I think, looking at the counts. But anyway, okay. Just wondering whether you checked that. But thanks.
Again, the recommendation is generated by the autoencoder, but the explanations are generated by the same method, right? Filtering or content-based or whatnot.
I have a question.
Okay, yeah, please.
Yeah, it's just a quick question. You mentioned that the transparency, people didn't really care much about the underlying mechanism. But is that domain specific, or is that do you think that's like in every domain?
Well, obviously, this was influenced by the domain, right? So this is in a post-study questionnaire after they looked at the explanations for movies. So obviously, their answers were influenced by the domain. I can't really say whether that would carry out to other domains. But if you ask me personally, yes, I believe that transparency is not as important as it's important to give information to the user, not necessarily the real reason why the mechanism of the autoencoder decided to recommend that movie and not another one. But that's just my take on things.
Okay, so again, many thanks, Guy, for this presentation, for this very interesting presentation. So let's move. Thank you very much. So let's move to the next paper, which is presented by Chunhua Tsai and Peter Brusilowski. So I assume it's Chunhua who presents the paper. And the title of the presentation is Exploring Users' Mental Models in Controllable and Explainable Social Recommender Systems.
Hi, everyone. Can everyone see my screen? Is it good? Okay, thank you. So we changed the title a little bit, but thank you for the comment from the reviewers. So the new title will be most likely the same, but we focus more on the user feedback and put our approach, the linguistic analysis, in the title. So I'm the presenter. I'm Chunhua Tsai from Penn State University, and this will be the paper with Peter Brusilowski and from the University of Pittsburgh. So hybrid social recommendation systems. So it's kind of being widely used in many, many different domains. And I believe everybody, all of us using that every day. And the main goal is try to reduce the information overload. And so try to eliciting user preference and proactively recommending relevant items. Usually it's powered by AI advanced, like a human applications. So usually use a larger scale of data, and you have multiple information sources, and the challenge will be the people actually using this system with a different information needs, so they can approach your social media to read news, so they actually approach your social media to find their friends, chatting to each other. So there's a lot of different information needs. And the second, this issue has been like addressed by like in the stream of research, like interactive recommendation system. And basically, we try to see how we can make the fusion, the reasoning more transparent, so we can try to solve this black box issue that, so make the most of the user will be able to understand, to be kind of make the interface of the system more usable. So that will be the goal. And we can see in the right-hand side, many of the previous work has been tried to propose different kind of user interface virtualizations, and in order to address this challenge. And this is our solutions. So our recently published one journal paper kind of talk about more detail about evaluation about this interface. So the goal, our approach is try to enhancing the controllability, explainability in the context of recommending people, like we are right here, the workshop or conference, when try to recommending attendees to meet at the academic conferences. It'll be before the pandemic, so people actually can meet to each other. But now it's kind of getting harder. But that's the goal when I designed the system. So in this system, you can see it is 4 different components. On the top, you can see a section A. I try to combine several different kinds of recommendation model, like a publication, your research topic, your co-authorship network, and your bookmark in the system. So the agenda, like you want to listen to these presentations. And if you can, you'll be able to control the preference of each recommendation model from 0 to 10, so you can highlight something you'll be more like to see more. So when you tune the slider, and the relevance bar will be in the section B, will be changing, so you can change the ratings. And the other thing will be you can be able to inspect the detail, like explanations. So when you click the section C, the explanation buttons, you'll be able to find some gyrations to show you, okay, publications, why this person, this researcher publication is similar to me. And if you see right here, it can show you like a bar chart. They say how strong the work for you and for the other researchers, and what's the overlap. So that's the idea. We try to provide this kind of interface to enhance the controllability and abilities by the virtualization and the sliders. And this paper has been, by like present in a detail about evaluation in the most recent published journal paper. But in this presentation, I want to focus more on one of the data we collect from the studies. So the research question will be, how do the controllable experimental interfaces actually affect the user feedback in the social decision process? And why we care about this? The social feedback will be, we're not kind of wondering if this can be a way, a format to measure the user mental model. So it's kind of a way to illustrate the user mental model to see, okay, if we have this component provided to you, how would you use them? Or maybe you actually don't use them at all. And how this kind of virtualization interface actually change your behavior, change the result you get from the system, and kind of furthermore change your mental model. So it's kind of a circle. And the most recent, the UMAP paper 2020, they have an interesting paper to measure the Netflix recommendation process. They ask the user to draw a diagram to tell how do you perceive the recommendation system process actually is working, and the user will be able to use this way to measure. And the user feedback will be the way we try to measure in this paper. So the data will be collected from one control study. So like I just introduced it to you, there's 2 interventions in this study. Intervention 1 is I provide you controllable sliders. Intervention 2, I provide you explanation interface with 4 different like explanation virtualizations. And we said within subject study, and we kind of balancing square, and we have 50 different participants. And the interesting here will be actually when try to invite the subjects to complete one information seeking scenario. So everybody doing the same thing, but they kind of make their best judgment to select the attendees from the conference. And interesting point here is that we ask them to justify their decision. So every time they make a selection, they need to tell this, there's a small pop-up window to collect, they say, can you tell me why do you want to follow this person? So there will be the way, there's 2 purposes for that. The first one, I want to know actually, how do they feel? How do they make this decision when they click the following button? And the second way will be in my experiences, many of the users, if you ask them to follow somebody, and many of them will just quickly follow the top 4, like the top couple like recommendations, and they don't actually think about why do they want to follow them. They just want to finish it as soon as possible. So there will be a way that we can control about this factor. And after we collect all these statements from the users, we perform linguistic analysis. Because we kind of, based on literature, we find out from the linguistic research, the word choice that in your writing can be kind of a way to show your writer's psychological states. So we try to see if we can use this approach to measure the user's mental model while interacting with the system. So give you an example, the social decision and justification here. So the user be invited to the study to finish this task. So I asked them to say, could you please follow 4 scholars from the conference attendees, and they will be more relevant to your research. So it's personalized. Everybody will be different kind of with a different, they should select from a different set of researchers. And the ideal candidate will be the scholar who the system identifies more connected to you. So it's more like a pro-social co-authorship network. So it's also personalized. Everybody kind of with a different network. So I just try to make this kind of task more real. So everybody will be able to follow, because most of them, they are graduate students and PhD students. So they can get the idea that how they should do using the system. And what I mean, the reason, so when you click the follow, for example, if I want to click follow Dennis, when I click the follow buttons, there's a small window will pop up to say, please tell me why do you decide to follow Dennis? There can be several reasons, can be any kind of reason. They say, I know this person, I know this scholar, and in person, I like the research, I like the paper, I think the ranking is on the high or something. You can provide any kind of reason. Just tell me, why do you decide to follow this one? So after the data set, we have 829 statements, and the length is kind of a little bit short. So the average size for the sentence will be like 10 words. So because it's kind of in the real like social decision process, it's kind of pretty hard to ask them to write an article every time they make a decision. So the sentence is a little bit short. I can give you examples. For example, using the baseline interface means like you don't have any control sliders, you don't have any explanations. the user will say, oh, I decide to select this scholar because we have high this publication similarities, and things like research in a certain topic is very interesting. And how do they get this information? They will be able to check the profile of this scholar and see what's their publication papers, so they can get out this they can get this information and provide in the dialog box. And the other example will be if you have an explanation, now you have an explainable interface, so you don't have control, but you have explanation. Now you can give more information, you get more information from the system. So the feedback from the user could be, his work in social media and the recommendation system attract me, and he has a close connection with my advisor, and that information will be only provided by the explanations, because you need to check the social network, virtualized social network, so you'll be able to know between you and to that person how far, how many degree between you and you two, and how you can connect to each other, maybe to your advisor, something like that. So that will be the way to give you an idea how the statement look like. So we apply using LIWC, it's a linguistic tool. And in this tool, they define several dimensions, and we pick 3 is most relevant to our data set. So the first dimension will be the grammar. So to see how many like big words, for example, how many words you use, how many big words, like the words with more than 6 letters. And if you're using more big words, it seems like the writing is more complicated, things like more so forth. And you can think about how many numbers, how many comparison words. And I have some sample here, like a greater, best, after, or like interrogatives, like a how, when, what. So I want to see in the grammar, what's the word choice in these dimensions. And the second dimension will be the summary language variables. So there will be a summary score provided by that tool. It can tell you how, for example, like how analytical thinking, the score higher means like things like the article is more thoughtful and analyzing something. And Claude means like they feel empowered, in control, and more confident. And insensitive means like they are kind of analyzing something and showing the emotion and emotion tone, something like that. And the third dimension will be the psychological process. Now it's in detail talking to you what kind of word you use. For example, is there more positive word, negative word, social, female, male, perception, motions. And you can see some examples like she, for example, if in female references, the more like you can use girl, woman, her, she. If you're using more this kind of word, the score in the female reference will be higher. So that's the purpose when we use this tool to get all these numbers. And there will be the findings. I just, we have a detailed report in the paper, but in here, I just highlight most interesting finding to you. So when we find out after analyzing, if the user using a controllable interface, they use fewer big words, means like the writing is less complicated. And also they use more interrogative words like when, what, why. And things like imply the user is more like in searching or comparing more. So this is an example. For example, the user will say, I decide to follow this scholar because the second highest relevance when the co-authorship similarity is set to 10. So it's with the conditions, when I try to do this to the system, and now this person is on the second rankings, so that's the reason I decide to follow them. And interestingly, if you provide explanations, the user using less word in general, it's like more like 50% less. It seems reasonable because they think that if you read more explanations, it takes some cognitive loading that from the user, so they don't want to spend that much time to write a sentence, the statement, or each of the selections. So overall, the word is less, but it's using more adjective and the big words. So by the definition of the linguistic analysis, it thinks it's more soulful writings. Like to me, it's like implied these things like the explanation giving the user more assurance, so they can confirm what they understand. So they check the explanation to see if this is really true. If this is true, and I trust, it seems like more confident and trust the result. For example, I would say the user 23 say, I choose this article scholar because it's highest recommended, ranking #1. and it's a same affiliations, and we have a fewer population words. It's not the numbers, not the score, it's the words. It's in detail overlap. So this kind of overlapping things like confirm, okay, this scholar will be the good choice. So I would like to follow them. And our second finding is that if you provide controllable interface, the people feel more in control. This is definitely they feel in control, but it's kind of showing by the club score. Means like the people feel it's more active and feel in control, feel more powers. So you can see the example here, the subject 45, they say, oh, we can do something, we care, and we can cooperate in the future. So you can feel like this person thinks like, find out, I decide to follow this scholar because we can do something together. I'm in the control position that more like to do something together actively. And if you do explanations, it seems like the higher analytic score means like the writing, the statement is more software, it's showing a higher quality and showing the judgment from the users. For example, the user will say, oh, it's a good network, showing in the co-authorship similarities. The good means like the user check the virtualization, they find out, oh, this network distribution thinks is good, reasonable, shortest degree, and I like the virtualization, the network, so I decide to follow them. And it's most relevant publication to my interest among all. So you can see the writing, the use of the word is more complicated a little bit and showing the higher qualities and showing the user actually confirm and making some judgment about how the information received from the system. And next one is that the psychological process variables. So the controllable interface, the user uses more social, motion, and focus on present tense. It's showing like the user is kind of using the tool more personal and given a subjective decisions. Like for example, the first subject 15 say she's similar to a person I knew. So where we share a strong topic together, similarities, or he goes to many different research conferences, so we have no overlap in connections. That will be the way to showing more motion words, something's moving. It's something maybe contribute by, because you can change the sliders. So it seems like something is motion, focus on present tense. And interestingly, we can kind of give some surprise result from the explanation one, because we find out the user using less gender words, like she, her, something like that. So it seems like the statement becomes more neutral and objective. So for example, this subject 40 would say, this author seems to have a wide variety of subjects and is quite far in the network graph. So compared to the controllable, it say, oh, I like her work, I like her publication, or she is something, he is something. And these things like the gender information is not that appealing if you have more information that make the whole recommendation model become more transparent. This will be the surprising finding and very interesting to see this. And so our discussion one, the conclusion, the discussion from the controllable interface, we find out the user's mental model thinks it's more like a filtering and controller recommendations. It makes the conditional decision process become more subjective, so they can make a decision on their own, they feel in control, feel more power active. But it may impede the user to inspect the detail for the social recommendation. So we can find out they use less big words. The writing analytics things like score is lower. But if we have explanations, the user will be able to confirm and browse through the recommendation. It seems like it's showing the most software decision making and more objective. So we find out the gender information is less appealing. The people can make a judgment from the information they got from the system. But the downside would be the explanation can overload in the user, so that you can see they use less word in general to provide the feedback. It's things like evidence, not everybody will be appreciated using the explanation because that's a lot. You need to inspect all the detail. You have 4 different generations, and you need to write a statement after that. It seems like too much to the user, for some of the user at least. So the conclusions. In this paper, when perform linguistic analysis on the user feedback, the user generate text in a controllable external social recommendation system for conference context. And this is our preliminary attempt to understand the user's mental model and using the text from the users. And it will be right after each decisions. And we discuss the 3 linguistic dimension, grammar, summary, psychological process, and we show some like interesting tendency the user actually showing a little bit different when they get a different component from the interface. And we provide some empirical evidence on these interface components. and how to discuss how this affect the user's mental model and discuss the design implication in the papers. And some takeaways, I don't know why this, sorry, some takeaways. So we kind of find out both controllable, explainable interface contribute to a different level of transparencies. They can be the process, can be the fusion process, can be the recommendation model algorithms, can be anything different kind of level of transparencies. And we argue I think it's pretty important to further consider users' mental model when we design, provide this controllable, explainable interface to them. And for example, we need to consider code game loading, fidelities, to decide what the level of details and functionality, and also think about what's the purpose for design such a system or interface to the users. And based on the user need in different contexts, we need to find out how detailed we should provide, what kind of function, what kind of information we should provide. And there's some open question here, like how can we, maybe I'm thinking based on the findings, it seems to imply like an explainable interface to help to ease the gender bias, make the gender bias less appealing, or maybe the other kind of bias. And we don't have, that would be, we don't claim that explanation can really do this, but things based on the finding, we find out the tendency here. It would be worth to further explorations. And how can we measure the user's mental model? That would be in different contexts. It can be context independent, can be in different stage of user making decision. This is quite complicated. I show two examples here. The one is from the other literature. They draw something, the figures. And here we use the user generate text. And the other one can be using the other format. There will be open research questions. And how can we design adaptive explanation based on a user mental model? And that will be something that we will continue to work on this topic in the future. So thank you. I'm happy to take some questions.
Thank you very much. So please post some questions. Questions from the audience? So I have one. So what I did not really understand in detail is you have many different aspects that could be taken into account by explanations, especially in this scenario in terms of recommending researchers. What I would be interested in, what from your point of view are quality criteria. So what is a good explanation if you go the next step and try to integrate your concepts into a real running system? I think you have these quality criteria in mind because you are not able to show all these explanations to a user.
Yes. So I think the user, based on in my experiences, so the user need different level of transparencies. And most of the design here, to be honest, I think is more suitable for the people with certain background knowledge. For example, if you want to understand this two-way bar chart, it would be good you get some idea for distribution, so you know that it will be the turn frequency, and to kind of roughly calculate the overlap between these two distributions. And for the people without this kind of background knowledge, they will kind of tend to ignore this explanation because it's not that useful for them. In this case, maybe just give them some rationale would be more useful. Like I don't actually need to tell you the detail about how this recommendation model produce all this recommendation to you. It's more likely to tell you, oh, okay, so you have a similar in text, and just to highlight some keywords, maybe they can work in better than a very detailed way to have detailed visualizations. So I can give you an example, like I find out the people, for example, in this study, we have two sets of users. One is from master student and the other one is from the graduate PhD students. So the PhD student they got some research experiences, they know how to design the user study, design recommendation model. They will be more desire to see the detail to compare more like a statistic numbers right here. But for the master student, if they don't have this kind of background knowledge, they would prefer to see something simpler. So just directly tell me why this is good. And if this makes sense, I will accept that. So just give me a rationale. So I think that will be the direction to go to find this, like what I say in the conclusion, that maybe we need to provide a different level of detail to different kind of user, and they will be relevant to their background knowledge and mental model when they approach in the system.
Okay, so many thanks, Chunhua,
Yeah.
for your presentation. And we have to move to the next presentation,
Sure.
which is on recommending interesting writing using a control level explanation-aware visual interface. So let's move to the next presentation. So are the authors here?
Yeah, I'm here.
Okay.
Okay, can you guys see my screen? Okay.
Yes.
Hi, my name is Rohan Bansal, and I'm presenting our paper on recommending interesting writing using a controllable, explanation-aware visual interface. So the first issue that our experiment was designed to tackle was that of information overload, which has been exacerbated in the 21st century due to the advent of technology, the internet, and social media. There's really two major ramifications of this issue. Firstly, we are no longer able to focus our attention on a single topic. And this is natural because as we're reading something or watching something and more information comes in, our attention is naturally diverted to the new information. And this is a seemingly endless cycle. And this leads to the second problem, which is that we no longer have a true knowledgeable understanding of topics that actually impact us on a day-to-day life, whether that be related to our career, related to our family, our personal life, or even things like politics that actually have a material impact on our communities. And this was something that me and the other collaborators on this paper were increasingly unhappy about, and something across the globe that people have expressed frustration with. And so we can see some of this divide here in terms of news feeds, both online and within print media. So here we have a couple Apple News spotlights, which are news feeds that Apple sends to iPhone users. So the first one reads, "The very, very messy ways the pandemic could end, plus a simple, delicious anti-inflammatory meal plan and more weekend reads." The one on the bottom goes, "How the coronavirus could change our world forever, plus the incredible power of walking and more fascinating weekend reads." So immediately you can tell that these news feeds are not very organized, they're relatively polarized, and they don't foster that type of serious focus on one topic. They both start with something very important, which is the long-term ramifications of COVID, and they quickly go to something much more trivial and something that's designed to take the user's attention away from what they're probably more interested in reading. On the right, we can see a similar thing where we see TV and computer craze is giving kids cancer in all bold. There's obviously much more nuance to the paper or the research being presented in this article. And so users' attention is drawn in, but then they're left unhappy with the quality of the content that they actually end up reading. So zooming out of the larger scale issue and focusing more on our experiment, the browser is a news curation company that sends out a newsletter of 5 articles every day. And users, it's a subscription-based service that users pay for. And a man named Robert Cottrell reads 1,000 articles a day. He's done many interviews on this. And now obviously no man can read 1,000 articles a day from beginning to end, so he has to skim many of them. But it is important that he reads lots of publications, lots of sources, lots of different types of writing. And our initial thought was there must be some way to bring that 1,000 number down to maybe something like 100. And this would give him more flexibility to actually read the content of the articles and potentially make better predictions. And so the first thing that we did was we tried out rank from set, which was proposed by Altasar and others in 2020. And this is a recommender system that uses a binary classifier where function F generates the logic predictions. And so for each article, beta J represents the word embeddings within the article, and those are summed together, effectively destroying the order of the words. And then X sub M is the overall set of words for the articles, so they are normalized by the length of that set to ensure that article word count does not play an oversized role in the predictions. This result is then multiplied with a user embedding, theta U, which in this case was just Robert's user embedding. And so because of the simplicity of this model and its flexibility, this could easily be extended to 50, 100, 200 user embeddings, depending on your personal needs and wants and what type of data you're looking at. To benchmark this, we compared it to BERT, which was proposed by Devlin and others in 2019 at Google. BERT is a state-of-the-art natural language processing model built on the transformers, which essentially generates scores between every single input and coding. And so because of this size and empirical evidence, we predicted that BERT would outperform rank from sets when it came to recall at 1,000. So we gave it a set of labeled data and we got the top 1,000 predictions, and the percentage of those top 1,000 that were actually quality writing were the metric we used to evaluate both models. So we predicted that rank from sets would overfit on the data set faster simply because it's much smaller and much quicker. However, we predicted BERT would have better performance. When we did this, we were intrigued to find that although our time hypothesis was correct, rank from sets actually outperformed BERT by about 5% on the same data set. And so this was an intriguing result because it was definitely not something that we were expecting, but it did provide validation that rank from sets could be a viable solution to the problem that we were trying to solve. And so because of the ease of use of this model, or actually we can first look at just comparing rank from sets and BERT head to head. So rank from sets has fast calculations, as we talked about. It's really a simple dot product, so it can be done on a CPU very quickly, whereas BERT requires a fairly powerful GPU to run. Rank from sets can be hosted on AWS's free tier, which we'll talk about in more detail later in the presentation. BERT obviously cannot. And the one thing to note is that BERT theoretically could provide better performance. And one way we were able to determine this was we used both models to generate predictions on new articles and sent them to editors at the browser. And we got relatively limited feedback in terms of the discrepancies for both sets of predictions. So both models are performing similarly, and it's possible that this specific data set may not have fit with BERT's approach, and more experimentation would be needed to make sure that BERT can't provide significantly better performance than what rank from sets did here. Now, because of the ease of rank from sets, we were able to set up a live demo, and we can see it here. It looks very similar to the screenshot in the presentation. And so we start with just a set of vanilla rankings of articles, and we have the top and least contributing words to the prediction here for the user to understand. We also have some sliders which allow users to control for specific topic words. So if we were to maybe want to look at crime and politics, we could upweight crime and politics all the way and click fetch. We also have a coronavirus tab, which is to recommend interesting writing related to the COVID pandemic, which is in high demand during these days. So once it loads, you can see some type of articles like the Russia report on interference, which is a clear intersection of crime and politics, COVID-19 in state prisons, and other things like that. So the sliders allow you to sort of control for your specific interest. Now, the mathematical premise of this model is still very similar to rank from sets. It's still built on that. All we're adding is we're taking alpha, which is a scalar value presented by the slider, and the sign product, or the sign of the dot product between the word embedding and the user embedding, so that a negative contribution becomes positive and not more negative. We also upweight the top 15 cosine neighbors based on BERT's vanilla embeddings to the topic word. So for crime, we would upweight the 15 words most similar to crime. And this is done for each of the topic words that we have included. The rest of the model is identical to rank from sets as presented earlier. And because of this, because of the ease and the simple, essentially one calculation being done, it can be hosted on AWS Lambda free tier. We've presented the code, it's about 50 lines at no cost. And you saw the fetch, it takes maybe 3 to 4 seconds to get back a new set of recommendations depending on the topic sliders that you input. And so this provides a low cost option for people like Robert and even individual users who just want to read something that they may not be exposed to normally. So looking ahead and seeing where this experiment fits into the general realm of news recommendations, Canopy is another example of a company that uses machine learning and has a focus on privacy for personalized news recommendations. However, they are not open source and they utilize human moderation in the middle. So they are slightly different than what we are trying to do. And Signal is an example of an open source company. And because of their open source nature, they've been able to build trust amongst their users. And we think that that is one of the biggest aspects of our experiment. Building trust and having users understand why their recommendations are being made to them is very important for feeling confident in the type of newsfeed that you're getting. And so this experiment was designed for companies like the browser who may not have the same developer or monetary resources as companies like Google. So if you know any other companies or individuals that would benefit from this work, feel free to email Rohan at rohan.page. And I would also recommend that you check out the GitHub, the browser/recommending interesting writing, to look at more detail at our source code and some of the approaches that we tried before settling on this. And I would like to end by simply thanking the other collaborators who made this paper possible. Thank you.
So thank you very much for the presentation. Question, please. So I have one. What I didn't understand in detail. I mean, you basically recommend some kind of content. What about the aspect of diversity in content recommendations? So if I'm a user who consumes the content, is there an issue with the sequence in the recommendation of the content? Did you think about that?
You mean in terms of diversity of publications and sources?
Yeah.
Yeah, so that is something that we thought about. And so ideally, the way to extend this experiment looking forward would be to have custom user embeddings. So if we were to have enough data for each user, we could understand more of what they prefer. Right now, what we're doing to recommend these articles is just taking a bunch of sources, getting articles from them, and then ranking them based on their topics. And so if we do look at the demo, we have some repeats in terms of sources, but we have a fairly good amount of sort of a diversity of sources like you talked about. But I think as you add more data and as you incorporate sort of the more human side, the user side of what they specifically click on, I think that would also help in generating sources or publications that are more unique to users and more diverse in their overall set.
Okay, are there further questions from the audience?
Yeah, I have one. So
Okay.
I checked the paper, very interesting presentation, thank you. And I checked the paper and you mentioned about the qualitative evaluations, but I'm wondering, can you tell us a little bit more detail about how the user actually perceive and what's their feedback when you show the system to them?
Right, so right now, most of the use has been editors at the browser. And so obviously, as I talked about, our focus was on improving their workflow. And so we did hear feedback that they were able to utilize our system to find new publications that they otherwise had not considered. They were able to find articles that they may not have read. And that's something I talked about extensively in the presentation, which is if you're reading 1,000 articles a day, there's no way that you can actually get through the content of each single one. So what this allows you to do is filter that down. So you may find, hidden gems that you otherwise would have skipped over. So that is something that editors at the browser have given us positive feedback on so far.
Thank you.
If we still have time, I think you found a great spot for the relatively complex controllable recommendation because you work with people who are professionals. They use it very frequently and the complexity would be appreciated. Would you also consider this interface as a potential interface for the user of your system? There's still a lot of content, although it might be already filtered out. But maybe within controllable interface for the user, they can provide a better experience for the end users as well, not only for your editors. Or you think it's basically not what you want to do?
You're referring to individual users, right? Like non-corporate users? Yeah, I mean, I think that this, as we work on improving the UI, I understand there's obviously changes that could be made, but I definitely think that independent users could have a place in this. I mean, as someone who reads a lot of news, I'm very interested by this project. It's sort of the inspiration for me. And the coronavirus tab is designed to do just that. So I think the sliders and things like that, if they're better labeled, maybe a little more intuitive, and we made it a little bit clearer about what the purpose of this website is, I definitely think that individual independent users could have a place with this product for sure.
Okay, thanks. I see one question. There's one question in the Q&A by Ivan. What exactly was the interaction protocol between user, Robert, and your recommender system?
So our recommender system, as I said, was given to editors at the browser to use on a daily basis. So they could use it and they could see the top predictions on it. And then they could look through the articles and see maybe a couple of them struck their interest, and they might put that in the final newsletter that's being sent out, or they see a new publication and they put that in the newsletter. Right now, the end user would be people who are subscribing to the newsletter. And so they would be the ones who would have given feedback on the specific articles. And like I just talked about in the previous answer, once we have independent users utilize this service, we could also better understand how they feel about their specific recommendations and whether the topic sliders need to be tweaked, whether the values need to be tweaked, et cetera, et cetera.
Okay, there's still time for one additional question. So from the explanation point of view, what are the open issues? So do you have some specific goals how you want to improve the explanations that you currently integrate in your system?
Yeah, so I think one of the things would be word filtering. We want to get rid of words that probably have no contribution to quality writing as such. And as I said, there's a lot more experimentation that needs to be done on BERT and other approaches. And so one of the issues potentially with this approach is we're breaking down word order. And so word order could have a serious impact on quality of writing for certain articles. And so in terms of the explanation, I think that rank from sets offers a very simple explanation, very simple mathematical premise for how recommendations are being made. So most users could have a somewhat of an understanding. But I do think that the UI needs to be better designed to make people understand what the sliders are doing, what the top and least contributing words are doing, and maybe a little bit more background on the math or the model being utilized.
Okay, so
okay.
You will be back next year to show your UI study then.
Yeah, hopefully.
Okay, Alexander, can I make an announcement?
Yeah, sure.
So in the chat of this particular talk, but also in the general chat, I posted the Google Meet link so that if people want to chat a little bit during the break, you can follow that link and find the other participants of the workshop. Of course, this is all voluntary. You might have to get some dinner or lunch or whatever, but at least it allows us to interact a little bit more than we can do using this platform. So the link is in the chats, and I will also share the slides with the upcoming session, and the link is also on that slide. So I think that concludes the session, but maybe Alexander wants to close. But
yeah, it's officially closed now. Thank you very much. So have a break of 1 hour and see you later.
Okay. Let me start the recording again. Okay, it's 7 UTC, and we're back at the last session of the Interest workshop. Welcome back, all. Happy to see you again. Session 3 has a set of diverse papers about context, diversity, and personal characteristics. We have 3 full papers and a short closing discussion session at the end, for which you're all welcome to join and turn on your mics. Before that, let's start with the first talk, which is about exploiting distributional semantic models for natural language context-aware justifications for recommender systems by Cataldo Musto. Musto will present this. Go ahead, Cataldo.
Okay, thank you, Martijn, for the introduction. This is a joint work with Giuseppe Spillo, Marco De Gemmis, Pasquale Lopes, and Giovanni Semeraro. In this work, we have tried to exploit the distributional semantics model to generate natural language justifications for recommender systems that are adapted on the different context of consumption of the items. So the topic we try to tackle through this work has been largely discussed throughout the workshop, and it is the well-known explanation problem. So we have a user who is interacting with a recommender system. He builds her own user profile. He receives a recommendation, but she typically does not know why she has received such a recommendation, because recommender system typically work as a black box. There is a plenty of approaches. There is a plenty of techniques to tackle this kind of problems. The recent approach that we have presented at the UMAP conference last year to tackle this problem was based on the exploitation of reviews. So was based on the idea of gathering some reviews discussing the item, processing these reviews through natural language processing and sentiment analysis techniques to get the opinions that are spread in the reviews about the item, in order to identify some relevant and distinguishing characteristics of the item that can be useful to better assess the relevance of the recommendation a user has received. So in this example, you can see a user who has received Stranger Than Fiction as recommendation. We have some reviews discussing the item, so we can extract some information from review and, for example, get the information that this movie has a funny yarn, has a memorable writing, has an interesting concept, and so on and so forth. So the idea that we tried to spread in this article was then to combine all these pieces of information that we obtained by processing the reviews of the items in a single natural language justification that supported the recommendation. So in this case, we fill in a template with some concept that was extracted from the reviews. So I recommend you this movie because people who like the movie think it has a memorable writing, and so on and so forth. So this is the current state of our research in this area. Through this work, we try to make one step further with respect to this research, because we try to investigate what is the role of the context in this pipeline, because we do know that context plays a key role for several decision-making tasks, and the recommender systems are no exception in this in this research line, because we know that contextual factors such as mood, such as company, they influence the selection of the most suitable item for the user. So unfortunately, there is no research, or there is just a little research investigating what is the role of the context in the explanation task. So the research question that has motivated this work is, shall an explanation be influenced by the context of consumption of the item? Shall the explanation be adapted on the ground, on the different situation in which the item is consumed? And this is what we've tried to investigate in this work. So the contribution that we propose is a methodology to generate context-aware, post-hoc natural language justification that exploit distributional semantics models. So this work has three main hallmarks. The first one is that our justification vary on the different contexts of consumption, as I said. The second one is that our justification are generated in have a post-hoc nature, so they are independent from the underlying recommendation model. And the third distinctive trait of this work is that they are based on a geometrical representation, which is fostered by distributional semantics models that I will introduce in the next slide. So these are the main characteristics of this work. This is a workflow that we have designed to generate such justifications. We have three main components, so we have three main processing steps. The first one is carried out by a context learner, whose goal is to generate a vector space representation of the different context of consumption. So we have as input a set of context and a set of annotated reviews, and we obtain as output a vector space representation for each context. Next, in the second step of this workflow, we have the context vector, we have a context of consumption, we have a recommended item, and we are able to identify, by using a representation which is based on distributional semantics model, all the most suitable sentences to be put in the explanation. Finally, in the last step, in the generation step, we put everything together and we generate our context-aware justification. So, in the first step of the processing, which is carried out by our context learner, what we basically do is to learn a representation of the context. So we have as input some content. In our case, it is a data set of reviews discussing the item, and we obtain as output a vector space representation of the context, which is based on distributional semantics models. I do not have time to go completely into details of distributional semantics models, so I will try to give you the intuition behind this representation paradigm, and I invite you to maybe to read the paper to deepen some concepts. So, in a nutshell, what the idea behind distributional semantics models that have been popularized by Ludwig Wittgenstein, who is an Austrian philosopher, is that the meaning of a word, the semantics of a word, can be learned on the ground on how the term is used in a language. So they are based on a very simple hypothesis, which is called distributional hypothesis, stating that words that share a similar context, so that are used in similar situations, in similar scenarios, or to discuss or describe a similar situation, they share a similar meaning. This is the idea. And it is a very effective idea because some of the most recent techniques in the area, also for deep learning, to represent textual content, such as word-to-vec or BERT, they are all inspired by this hypothesis. They are all inspired by the hypothesis that we can analyze how a word is used to get information about the semantics or the meaning of a word. To better understand what is the idea behind distributional semantics models, I will start from the end. I will start from the output that we obtain at the end of the process. The output that we obtain when we use the distributional semantics models to represent some textual content is a word space, which is a vector space where each word is represented as a vector. This is the final output. How do we obtain this output? This is obtained by building a matrix similar to this one, which is called term context matrix. What is a term context matrix? It is a matrix where we have in the rows all the terms that appear in the textual content that we have collected and processed, and in the columns the different contexts in which the word has appeared. A context can be a document, can be a paragraph, can be a sentence, can be whatever we want. It's a very flexible representation model. So in this case, in this matrix, we have encoded the fact that beer and wine are used in the same context, so they do share a similar meaning. What can we do through this kind of representation? Well, each row of this matrix is a vector. So we can extract rows from this matrix and we can use them as a vector in a vector space. And the intuition that the distributional semantics models try to spread is that a similar context of usage of a word led to a similar meaning. So beer and wine, which are used in the same context, have a similar meaning as well. So this is the introduction. How can we exploit these models for our goal? We designed the following pipeline, which is based on 4 different steps. The first one is the context definition. So that is a manual step, basically, because on the ground of the different domain in which we want to apply distributional semantics models, we have to define the contextual factors and the contextual dimensions. So, for example, in a movie recommendation scenario, we can define attention, company, or mood as contextual factors, and friends company, friends, family, and partner as company, bad mood and good mood, and as mood, and so on and so forth. So the first step is the definition of the context of consumption. The second step is the annotation. This is again a manually step that we have to carry out. What we do in this step is to take some review excerpt, some review sentence, for example, and annotate these sentences with the context of consumption in which this sentence can be a good explanation. So, for example, not easy to understand, requires a very careful vision, is good to support a recommendation in the context of consumption characterized by a high level of attention. Fairy tale, pleasant and enchanting, is good if we are enjoying a movie with family, and so on and so forth. So we have to repeat this process, this annotation process, over many sentences in order to do model want, so to encode the usage of terms in context. Next, in the third step, we, based on the annotation that we have completed, we can encode this information in a matrix, which is a term context matrix, where terms have the same definition that we have seen before, and in the columns we have the different contexts of consumption. So the information that we can get from this matrix is that careful is typically used for movies have with a high level of attention. Fairy is used for romantic movies, but basically mainly for movies to be watched with family, and so on and so forth. Finally, given such a representation, we can obtain two different outputs. We can obtain a vector space representation of the item by just extracting of the context, sorry, by just extracting the column vector from this matrix, and we can obtain a lexicon, which is the set of the terms in each column vector having the highest relevance score. So this is the final output that we obtain from this process. So we have content, we annotate sentences, we encode this information in a matrix. By processing this content, we obtain a vector space representation of all the different contexts of consumption. Next, given such a representation, the rest of the pipeline is quite straightforward, because in the second step, we have a context of consumption, we have a vector space representation for that concept, we have to identify the most suitable review excerpts. So this is a visual representation of what we do in this step. So we have a vector space representation of each context. We have an item, a recommended item, and we have some sentences in the reviews of this item discussing the item. Of course, we just limit on sentences expressing a positive sentiment. So what we do here is to identify the sentences that we have previously put in the vector space that are closer to the vector space representation of the context of consumption, with the assumption that the closer, the more similar the vectors, the most suitable is a sentence to support a recommendation and a justification in that specific context. So for example, if the context of consumption for the item is friends, in our justification, we will put the sentence, it's a classy, sweet, and funny movie. If the context of consumption is partner, because the movie has to be watched with the partner, we will use a different sentences, which is semantically closer to the concept spread by the partner contextual dimension. So for example, the movie has a very romantic end. So in the final step of the pipeline, we have the generation phase, which is based on a natural language generation technique. We have a fixed template, and we have this template, which is filled in through the review excerpts that we have previously identified. And as I have previously explained, the final output that we obtain is adapted based on the different contexts of consumption. And all of this is just due to the adoption of distributional semantics models for the different to represent the context. So in our case, we'll have concepts such as romantic end, intense plot, and so on. In the second case, we will have concepts related to laughing, to funny movie, and so on and so forth. So this is the what we do obtain through our pipeline. In the experimental evaluation, we have investigated two different research questions. In the first one, we tried to evaluate how effective was this pipeline on different configuration of the framework. In the second one, we compared our methodology to different baselines. We carried out a user study in the movie domains with 273 subjects. As metrics, we used a questionnaire based on the widespread metrics of the paper by Nava Tintar and Judith Mastoff. As parameter of the workflow, we varied the lexicon that we used, so single terms or bigrams and the combination of both of them. And we used a between subject protocol for question 1 and within subject for question 2. So we have this is the interaction with the web application. So we have a welcome screen. The user indicates the context of consumption of the item, so attention, company, and mood. The algorithm generates a recommendation and a justification, and the user has to evaluate through these sliders the different metrics through the questionnaire. In the second, of course, the configuration he is interacted with is randomly generated. In the second research question, we have a comparison to baseline. So we have our justification as justification 1 or 2, or it is randomly generated as well, and the baseline as the other justification. And in this case, the user has to indicate which justification she prefers based on the different metrics that we took into account. Here you have the results. The first outcome that emerged from the results for the first research question is that we obtained the highest evaluation by using bigrams, which is an interesting finding because most of the approaches to generate explanations, they are based on single terms, so they are usually based on single keywords. Conversely, in our case, it emerged that bigrams obtain better results. And this is probably due to the fact that bigrams such as a romantic soundtrack, so the combination of two terms, can be more useful to better catch the semantics which is conveyed by a particular review excerpt. Next, in the second and third experiment, we have compared our approach to both a non-contextual baseline, so a justification which is the same for all the different contexts of consumption, and a justification which is based on a static lexicon. So for each different contextual dimension, we have a fixed lexicon of terms which is used to identify the review excerpts. In both the cases, what we have obtained is that our justifications are preferred by the users. So we have a recap here. I think it's too late, so I will go to the future work. What we try to do is to generate personalized justification and evaluate post-hoc nature of our framework. So that's it. Thank you.
Thank you, Cataldo. Are there any questions? We have about 5 minutes left for questions for this talk. I don't see anything.
So one question I had is, so for the user-centered results, so the questionnaire items, were those results significant? Because they, like most of them looked kind of small. So I wanted to know if you tested those for significance.
I shall share again the screen, maybe. Just give me 1 second. I can anticipate you that we got a significant increase just for some of the metrics, because yeah, I can confirm that they are very small for some of the comparison. They were significant for transparency by compared unigrams and bigrams, and for the trust, by comparing again unigrams and bigrams. They were not significant, with p set to 0.05 for both persuasion and engagement. This is what we do obtain from the statistical analysis of the results.
Okay, thanks.
Any other questions? I do have one, so.
I have one.
Okay, go ahead.
So in your generation mechanism for the explanations, I do not understand it in detail, but is it guaranteed that in every case you generate reasonable explanations, also explanations that make sense, or is there some chance that also some, let's say, stupid explanations are generated?
Well, no, I won't say they are stupid. No. What can I say is that we made some deeper natural language processing on the text to make sure that the sentences that we put in the explanation are we'll say correct, syntactically correct. We made some parsing. I did not have time to go into these details of the processing, but we made some parsing of the sentences to make sure that they could correctly put in the template we have prepared. So for example, we just selected the sentences in the third singular person, for example, or something like this. We use some heuristics to filter all the sentences that we had in the data set to make sure that they could fit in the template.
Okay, thank you.
One question I had was, you only took explanations that had positive sentiments. Can you explain why?
Well, this is something we are still discussing. The very intuitive idea is that we wanted to focus on the positive aspects on the item, not to try to convince you to enjoy that item. No, but yeah, this is somewhat limited in our opinion. It could also make sense to highlight both positive and negative aspects of the item, because if you want to better inform the user in making maybe an informed decision about the item, it can make sense to identify, yeah, of course, positive aspects of the item, but also negative aspects of the item, and put everything together in a single explanation. So this is something we will certainly try to do as future experiment about this.
That might depend also on the situation. I think if you're explaining one item, that might be different than if you would explain a rank. Because if you want to explain why one item is better than the other, then you might need the negatives. But related to this, I remember that older models like latent semantic analysis, which is maybe related to what you do with the distributional semantic networks here, always had trouble with negations and words like not. So for example, you might give the wrong explanation because actually there was a negation in the text that you basically lose.
Yeah, I partially agree, because more recent technique for sentiment analysis, especially supervised techniques, they are not based on the single negation that can be in the text. So they are more solid for this kind of variation in the text, so they can try to handle this kind of situation. Okay. So yeah, it can happen, but I think that more recent techniques for sentiment analysis can be good to tackle it.
Okay, so you could do it, but for now you didn't choose to do it. Okay.
No, so, we didn't. Okay.
Thanks a lot. We have to move on to
Thank
the
you.
next speaker. The next speaker is Yuka Hutamaki. I hope I pronounced that correctly.
That's perfect. Yes, thank you.
From Tampere University, which is about diversity exposure in social recommender systems. And the floor is yours.
Thank you. And the slides are seen by everyone. Yes.
Yeah.
Thank you. So yes, indeed. And this is collaboration between Junhua Tsai, who already presented in the last session, me, Thomas Olsson, who is also at Tampere University, my colleague, and Peter Brusilovsky, who you know. I was visiting Peter and the PAUSE team 2 years ago in Pittsburgh, and this collaboration took place at that time. And we are joining forces in looking at social recommender systems, which we both teams have been working on for a number of years now. And this is specifically about diversity exposure. So how to utilize social networks in recommending people. And actually, I'm going to be talking about some theoretical aspects related to this work, specifically social capital theory. I think that is the main contribution here. I'm going to be presenting also an experiment that Junhua and Peter conducted. That is an illustrative nature at this point, so we look forward to actually move forward with this work. So I'm really looking forward to your feedback on this topic. So yeah, I think this is established by now. So we are at a conference, and this is a suitable occasion for meeting people to form new ties. And for junior scholars and newcomers, such as me, being new to the recommender systems community. So I know a very few people, and obviously I would like to find people that I could be collaborating, I could be learning from, I could be reading their work and so forth. So finding relevant people, finding relevant groups of people, cliques, whatnot. So I'm kind of, there's a lot of randomness in this early attempts to identify relevant people. Maybe for senior scholars, such as Peter, for example, and the chairs in general, maybe they are kind of limited by the number of strong connections that they have. So they have very little time to kind of escape their network, if you will. They're bound in their existing network. So they may have a kind of a different type of a problem. So they are meeting the phases that they already know and have difficulty in escaping these connections. And there's some theory also backing up this kind of bounding nature of social networks. So this is an illustrative diagram coming from our Communications of the ACM paper. The link is on the top bottom right part of the picture. So there is the active user marked by the red dot, and the size of a node represents similarity between the active user and the other actors in that network. So this kind of shows that, or illustrates, since it's simulated, that there would be potential connections for the active user in different parts of the network. And as you can see, if there is a similar person, it is actually likely that there are other similar people near that particular person. So if you would be able to identify those communities, we argue that that would be beneficial for the user. So there are two types of social capital. This is coming from Robert Putnam, even Mark Granovetter in the 70s, the strong and weak ties theory, that is very famous theory by him, saying that there are two types of social capital. So bonding social capital is these strong ties between people and their close connections. Whereas bridging social capital is connections that goes beyond their day-to-day or otherwise strong connections. And the Granovetter's paper is titled The Strength of Weak Ties. So he argued already in the 70s that these weak ties that connect people to beyond their daily circles or their common circles are actually sources of novel information. So these connections may be difficult to manage in a way that it's hard to communicate with people that are kind of beyond your usual scope. They may have different language, they have different vocabularies, they have different values, beliefs, and all that. But again, they at the same time, they are potential sources of information that is genuinely new to you and your community. So they are worth pursuing. So there's this notion of social diversity exposure, or maybe it's exposure diversity. In any case, the idea that is probably familiar to you, to many of you, is that by exposing the active user to people, actors beyond their most likely connections, we are able to we might be able to serve them with relevant, valuable connections. Social capital simply means that your capability to conduct something is actually dependent on not only you, but your connections and the capabilities of your connections. So if you have the right kind of a social network, you have a lot of social capital, because you have people that you are connected to that can help you in pursuing your objectives in an effective way. Yes, bridging and bonding social capital, their connection to strong and weak ties, I also already mentioned. Also, there is this line of research by Bert that argues for the importance of brokerage in a social network. So for example, on the right hand part of the screen, you have the kind of solid lines for strong connections and the dotted lines for weak ties. And Bert argues, also Granovetter argues, that should you be in a position that bridges individual communities, that is a favorable position for you individually, because you become a source of novel information to your communities. So it is a favorable position to an individual actor, and it is supportive also for their communities. Bourdieu highlights the dynamic nature of social capital. So it is actually an ongoing process and should be treated like that. So of course that kind of goes beyond these individual experiments that we are able to run. But for example, the platform that we are now using seems like a promising approach for this. However, it would be nice to be able to use the platform throughout the year, not only during the conference, to be able to actually pursue this kind of dynamic process of identifying new connections and making use of the connections. So then a few words about the mechanisms that drive the evolution of networks. So people want to meet similar people to themselves. So there is this homophily bias. So the more similar a person is, the more likely two people are able and willing to form a connection. This is nicely described by Kostinets and Watts in their paper. Another mechanism is triadic closure, which means that if A and B have a strong connection, A and C have a strong connection. It has to happen that B and C will also have a strong connection. So this triadic closure is another mechanism that drives the formation of new connections. And so if you teach a computer a way to create new connections in a network, you are very likely to teach these two mechanisms. And we argue that this amplifies the formation of these types of connections, which is the kind of, it's the bonding type of social capital, not bridging type of social capital. Bonding type is also very important. However, that is such a likely scenario to happen that we argue that when developing these social recommendation systems, we should try to optimize the formation of weak ties, the bridging type of social capital. So indeed, these two mechanisms exist, and like said, if we would teach an algorithm just with data, we would be reproducing these mechanisms, and to kind of counterbalance that, we suggest that the identification of weak ties is a strategy worth pursuing. And so we did. However, as you will see in the paper, where we have more details on the experiment, we didn't have enough data. We didn't have enough participants to actually allow us to draw any conclusions on this specific study. We will have to follow up with a more rigorous user experiment in order to actually show results. However, the idea here is that we were using two different interfaces, one of which, an earlier version, you already saw in Chunhua's presentation earlier. So this relevance tuner, where you can adjust different levers to list people and identify potential people to connect to. Then we had another user interface which uses a scatter plot of the same features. So you have two of the features visualized at one time, and you are able to explore the potential connections in a scatterplot style and click through the connections. And what we did is two things. So we ran a survey asking about the preferences of the users of these two interfaces, learning that the users preferred the relevance tuner, so this interface that Chunhua was already presenting earlier. However, when we look at their click patterns, so the way they interacted with the user interface, we saw a more favorable pattern rising from the scatter plot based interface. So the dark nodes in the network are actually people authoring in a conference joined by co-authorship network connection in a single conference, a single proceedings. The light nodes are attendees of that conference that didn't author but participated, and green nodes are the active users. And the green connections are clicks by the active users to other users in the network. And so the main pattern is that, as said, there aren't not that many users in the experiment. However, in terms of social diversity exposure, the scatterplot based interface was performing better. However, the users preferred the other user interface. Some reflections to conclude the talk, and then I hand it over to you guys for comments and questions and suggestions. So the first thing is that capturing real life social networks. So obviously this is a major issue in a way. I mean, for academics, there's plenty of data on us, and fortunately, the types of communities that RecSys is a part of, you guys have very solid data about conferences. So this is actually doable. So you have 10 years of conferences, all the co-authorship data out there. There's DPLP and other services. So there is data that actually can be used to create that social network model that is the starting point of all of this. So now we are, well, I would say that we are we want to be kind of nudging the user. So we want to be kind of taking decision for the user that we want to expose them to social diversity. However, there are, of course, other strategies, such as transparency, that is mentioned in the summary article for the workshop. So transparency is one approach for transparency of the network, like showing the network, showing the social network. And of course, we should explain the user why they should be trying to find those connections beyond the usual suspects. However, it is actually true that people are prone to homophily and triadic closure. So we've been running some other experiments where we actually people, the perceived familiarity of a user, of an actor, predicts the likelihood that a person wants to pursue a connection. The more familiar, the more likely they are to follow up with a particular recommendation. So it is a pattern that is really hard to break, should you want to break it. So giving arguments, like in the previous talk, I think it's an interesting approach. So how could we develop these systems that would give arguments to the user that they would actually want to pursue a particular connection? I think it's an interesting approach, definitely worth more thought to to argue for the importance of social diversity and the accumulation of bridging social capital. And I'm kind of bothered by the whole nudging idea. So I guess, I don't know how much this is discussed in the community, but technology is never neutral, obviously. So who are we to develop an algorithm that it's better, is more intelligent than the people with their biases? So of course, this is a bit of a thing that keeps me thinking. Is nudging an approach that is viable here? And of course, I'm interested in this in this type of take to kind of introduce social theory to recommender systems research, which I think you can also treat as something that is data-driven, is technology-driven. You don't need too much theory. You just want to let the data speak, let algorithms speak and do their thing. So do we actually need this type of theorization? That's it. Looking forward to your questions and comments.
Okay, thank you, Jukka. It looks like Peter has a question, raises his hands.
Kind of really odd because I'm a co-author, but I really have a question. So in the RecSys mainstream, there was a very interesting paper which tried to do modeling of the recommender system process, assuming that what user wants is a kind of similarity. He watched the movie, he wants kind of like that. He listened to song, he wants kind of like that. And the whole point of recommender system is trying to find that similarity in multiple ways, collaborative, content-based, and reveal to the user, right? Making it easier. What you're pointing out in your social prospect, that in fact is not probably a good thing, because in diversity exposure or in social capital, finding something close by, which is very similar, is not really helping very much with your social capital, right? You need to jump far. So you kind of, to some extent, you're introducing a very different kind of recommender system. I mean, value-based, right? Don't think about similarity of closures, think about value, like how much this person adding to your social capital. Is this kind of correct interpretation of
that is exactly what we are saying, and actually that thank you for the helpful comment. I think this is two parts. So actually, if you would take this kind of simplistic approach and you would try to find similarity in terms of content and interests, but kind of as far as possible in terms of the social structure, I think it would be an interesting strategy, so that you could still measure your vector, the vector distance in terms of the content, but try to do that in a way that you find candidates from as far as possible in terms of the social structure. Would be an interesting experiment.
I think that we are facing the same problems. If we, for example, we have tried to do genre explorations or helping people to improve their diet or stuff like that, you also not want to recommend them what they like right now. So I think there's many cases where actually recommender systems could step out of the similarity. I see there is a question on the Q&A from Alan Stark. A reflective question: if you provide users the tools, visualizations, explanations to make social decisions, would you regard that as more ethical or more responsibility still at the user side in that sense?
Yeah, I mean, that is, I would regard it as more ethical, but I have my doubts on the users, because we've been running, actually I was showing, the slides are on Twitter. So my Twitter account has the slides, and there is one more slide that has a bunch of papers, additional papers that we've been doing, and there is a specific paper currently under review where we were looking at this topic further, and that shows that really we are showing people from near their current social position a bit further away, and then more far away, and they really prefer the connections that are familiar to them and similar to them. So
yeah,
I'm actually I'm a proponent of visualization, but I'm not sure if that is a way that we can actually convince the users.
It sounds like you need better visualizations, or at least people don't really understand them right now. If I also look at the paper and your results, they think more like in terms of usability rather than in the goals or that they can achieve with having this.
Yes, agreed.
So it could also be that you might want to check how to evaluate this better by also looking at what sort of questions we ask these users.
So definitely it's the whole evaluation, the way my colleague Thomas Olsson, he's very much into, he's a Kai goer, and he's more in Kai than recommender systems. So that, and he's also supervising Yekaterina Olshanikova, who is actually looking at this evaluation approach, and she's finalizing her PhD these days. So it will be interesting and exactly on this topic. Evaluation of these types of recommendations.
Yeah, so I see Bart coming in. Bart, do you have a question, or?
Yeah, I was wondering. So this system is kind of looking at one-to-one connections. I wonder if the solution could be groups, right? I wonder if you can recommend groups of people to join together. You can always include someone who's a little bit more similar, and some people are a little bit less similar, like a little bit further away. So I wonder if in a group setting, and there's a whole big question of like how big should those groups then be, but if there's a way to increase the weak tie aspect that way.
That is definitely, thank you for that. I agree. Of course, it adds to the complexity even more, but it would be super interesting. And take in conferences, you would have these sessions where you would, become connected with a bunch of people, and then your job would be to figure out why. And maybe you receive some clue. Maybe you receive a paper, your diagram, something to talk about. It would be very interesting. Thank you.
Okay, thanks a lot. It's time to move on to the final paper of today's workshop.
Thank you.
Thanks a lot for this nice discussion. And Yeah, so thanks for unsharing your screen. So the next presentation is by Ala Slaiti. You might, sorry for mispronouncing that, perhaps. The influence of personal traits on persuading recommender system users. Ala, go ahead.
Yeah, thank you. Okay, so hi everybody. I hope you hear and see me well. Okay, so my name is Ala El-Slaiti. I'm from the University of Ottawa in Canada. Today I will present a work entitled The Effect of Personality Traits on Persuading Recommender System Users. This work is co-authored with Professor Thomas Tran from the University of Ottawa. The agenda for this presentation is I will start by introduction. I'll give a brief background about the main concept of the work, mainly about persuasive principles and users' personalities. Then the problem statement and the goal of the study. After that, I will discuss the study design. Then I will show the results and the data analysis, and finally I will conclude the presentation. Persuasiveness has been introduced to the computer information technology area in many areas of the CIT, which includes but are not limited to healthcare, education, and lifestyle. Also, it has been introduced to other applications which are not persuasive by nature, although they have some persuasiveness, maybe latent goals, such as recommender systems. So in the social sciences, there are too many persuasion principles. Psychologists have introduced many principles, but the one of importance for our work is the Cialdini's 6 principles of persuasion, also known as the 6 weapons of influence, which have been studied widely in the social sciences. These principles are reciprocity, scarcity, social proof, consistency, liking, and authority. And by the way, there is a new principle, 7th one, added to these 6 principles. But at the time when we created this study, these were the most known principles. Even until today, I think many of the studies just consider these 6 principles. So also psychologists have extensively studied humans' personalities and their characteristics. The Big 5 model, also known as the 5-factor model, is the most widely accepted personality theory. It's a hierarchical organization of the personality traits of humans. It contains of 5 core factors, usually known by the acronym OCEAN or CANO. Each factor involves a set of common facets. The Big 5 personalities are openness, conscientiousness, extroversion, agreeableness, and neuroticism. Each trait represents a continuum, and individuals can fall anywhere on the continuum for each trait. So they are not a 0-1 traits. So we don't say that X person is an open, 100% open person, but we can say that that person is high in openness, for example, or low in openness. Also, these 5 factors are known as relatively stable. They are stable throughout individuals' lives. That's why they are widely used. But with some slight exceptions, psychologists found that some factors are increased or decreased slightly with age. However, the researchers concluded that the changing trends were more in the facets rather than in the big five traits. So they said that the big five traits are relatively stable. The problem statement. So there is almost a consensus or a consensus in the literature that persuasive solutions cannot be treated as a one-size-fits-all. Those researchers of persuasive and technologies have been directed toward personalizing these solutions. And researchers have recently started investigating how to personalize these persuasive solutions. And they have started investigating how users respond to these solutions and to the Chaldean's principle in particular. Nonetheless, a limited number of researchers or research discuss the influence of user personalities on the effect of these principles in the domain of recommender system in particular. And most of these research were either not designed for the recommender system area, or they discuss the impact of personality in isolation of other factors such as the application domain. Having said that, this paper aims to fill this gap by investigating the effect of personality traits and their interaction with the application domain on recommender system users' susceptibility to the 6 principles of Cialdini. In particular, this research tries to answer the following 2 research questions. Research question 1, do personality traits of recommender systems users affect their responses to Cialdini's principles of persuasion? And the second research question, to what extent do users' susceptibility to different persuasion principles affected by the combination of their personality traits and their recommender system application domain? To answer these research questions, we designed a questionnaire. The questionnaire was disseminated using the SurveyMonkey platform. It consists of 2 parts. The first part is the personality test. The second one is about the persuasion test. In the personality test, we deployed the Big 5 inventory, which is one of the most popular questionnaires to evaluate the 5-factor model. This inventory was introduced in the late 1980s. The inventory is known as BFI 44 because it consists of 44 short phrase items. The second part, the persuasion test, involves 3 sections. These 3 sections represent a general section, which is not tailored to a particular domain. This part is used to evaluate or to answer the first research question. The other 2 sections are tailored to two recommendation domains, which are e-commerce and movie. Each of these parts involve 6 persuasive sentences. Each sentence represents one of Cialdini principles. So we have 6 persuasion cues in each part. And each of these statements is followed by a 7-point Likert scale, where the participants give rating for each statement. The rating of the users or participants reflect the impact of the statement on their acceptance of recommendation. Particularly, the participants were asked to rate each statement based on the question, to what extent do you think that each of the following statements will influence your decision to buy an item? This is for the e-commerce domain, or to watch a movie in the movie domain. We followed a within subject design, where we asked each participant to complete all parts of the questionnaire. Participant recruitments. The participants were recruited through different means, including paper posters posted at the University of Ottawa and online channels such as emails and social media. We received a total of 329 responses. After filtering the responses, we retained 279 complete responses. After collecting this data and filtering the results, we analyzed them according to the two research questions. To answer the first question, this part of the study shows which persuasive principle is more effective for each personality trait, and it shows if there's an actual difference between different personalities in their responses to the persuasive strategies. The figure here depicts the average ratings for the persuasive principles, grouped based on the personality traits. The x-axis shows the persuasive principles. The y-axis is the mean rating for each principle, and the personality traits are represented by different colors. From the figure, we can see that all means are greater than the neutral value, which is 0 in our case. Actually, they are more than 1.5, which means that all principles found to be influential for all personalities. However, the degree of susceptibility or the degree of influential varies from one personality to another. The figure also shows that agreeable people, the orange color, are the most susceptible to three persuasive principles, which are reciprocity, social proof, and commitment. Extrovert people, the dark blue color, are the most vulnerable to authority and liking principles. So to further investigate the differences and to show a clearer picture, here we have in this table the persuasion profiles for each personality. The persuasion profile represents the order of the persuasion principles. It shows the order of the persuasive principles based on their ability to persuade the corresponding personality. So each row represents the persuasion profile for the corresponding personality. The principles are ordered descendingly from the most influential principle, order number 1, to the least influential, order number 6. So for instance, the first row shows that liking is the most influential principle for extrovert people, followed by reciprocity, authority, scarcity, social proof, and finally commitment is the least influential for extroversion people. As a general observation from this table, the table indicates that reciprocity and liking are the most influential principles in general, where reciprocity is more influential than liking. Now, to evaluate the interaction with application domain, how personalities interact in different application domain, we consider two domains. So this figure depicts a comparison between users' responses to the persuasive principles in the e-commerce domain compared to the movie recommendation domain. The figure contains 5 charts. Each chart represents the data for one of the personalities. For example, A represents the extroversion personality, B for the agreeableness, C for conscientiousness, and so on. For each principle, in each column, we find the persuasive principles in the x-axis. So for each principle, we have 2 columns. The blue column represents the mean rating for for participants in the e-commerce domain, while the orange represent the mean rating for the same participants in the movie domain. The common observation here in this figure in the 5 charts is that the means of all persuasive principles are different to some extent. For instance, in regard to rebellious personality, figure B, the means for all principles vary from one domain to another with some differences. So we can see that the differences in regarding to liking is more than the differences in regard to social proof, for example, but there is a difference. One exception to this observation is in regarding to the extravergent people, chart A. We can see that scarcity and authority have the same mean rating in both domains. The other principles have different ratings. This table depicts the persuasion profile for each personality over both domains, e-commerce and movie. It's divided horizontally into 5 parts, same as the previous one, based on the personality factors. Each of these 5 parts is divided into 2 rows that represent e-commerce and movie domains. As we can see here, most of the orders are different, except for 6 cases where we can see that the order, the same principle occupies the same order. Another observation that agreeableness and conscientiousness, the 2 profiles for each personality are completely different. Conclusion and future work. This paper discusses the impact of recommender system users' personality on the persuasiveness of the 6 principles of Cialdini. The analysis of the result received from 279 responses to our questionnaire revealed that the 6 principles are all influential. Also, it shows that personality traits affect users' responsibility to 6 principles, and the impact of personality traits becomes more significant if we consider them in with interaction with the application domain. Based on these results, we suggest some general guidelines that should be considered for designing a personalized persuasive recommender system. First, personality traits are an essential factor that should be considered when we design a persuasive recommender system. Second, personalities are not treated in a black and white basis. Our analysis did not show clear evidence that differences between personalities are statistically significant for most of the cases. Thus, we don't recommend treating users' personalities on a binary basis if your design depends on the 5-factor model. Although they are important, but they should be considered in some fuzzy approach, for example, or in a probability basis. And we are working in this work as part of our project. Third, personality traits are more effective when combined with other factors, especially with the domain of the recommender. As a future work, we are working on exploring other factors that are expected to affect recommender systems users' responses to the 6 principles. These factors include, but not limited to, user age, gender, and culture. Also, we should investigate the interaction between all of these factors or part of them with each other, and how this interaction may affect the influence of the users. And finally, it's necessary to study the impact of the persuasive principles in other recommender system domains, such as music and education, etc. Also, we should consider larger and different sample in order to come into a generalization of the guidelines. Thank you for listening. This is time for questions, comments, suggestions, please.
Okay, thank you. Thanks a lot. Any questions?
So I have one. You mentioned this as an issue for future work, but just so maybe you already have some recommendations. So should persuasive messages more or less focus on one persuasive principle? So if I explain something, I should exploit one of those principles you mentioned, or do you think that it will make more sense to combine different principles in one persuasive message?
Thank you so much for your question. This is actually part of our work. So this is an ongoing project. So the most important part of our work is that we are designing an adaptive framework to select persuasive strategies based on personalities. So it's better to have many persuasive strategies or principles and use them when it's more suitable to use them. And one more thing important: if you keep using the same persuasive principle, the user may persist to respond to that principle. This is something in the literature. So our recommendation is try to use different principles, and these principles should be used in an interactive or in an adaptive way.
Thank you.
You're welcome.
Sure we have, oh yes, 3 more minutes for questions. I have a question.
Yes, please.
So thanks a lot. I think it's really interesting to have this, to see this work after Michelle Zhu's tutorial, where a keynote where she's stressing the importance of personalities. The question is how we can personalize that. It's clearly we need to do deep research on using personality for persuasion, but in a realistic system, it's very hard to get as precise model as big five to do something useful. So probably need something in the middle, something which is useful, but maybe not as refined and precise. Of course, unless it's a fully based conversational system where you might have more chances to do user personality. In normal movie recommendation, Amazon shopping, it's very hard to do. So what are you thinking about that? Something not as advanced, but still useful.
If I understand your question, I think you ask how to know the personalities of the user.
How to make it practical. Of question, if the user answers a 40-point questionnaires before going to Amazon shopping, we can do personality-based recommendation.
Yes.
Nobody is going to do it. So something in the middle between nothing and a lot will help.
Yes, this is one issue actually. One issue is to know what are the personalities of the user. That's true. To be fair, I think there is a portion of the user who will to answer the PFI 44. The second option is there is a PFI, the short version of PFI 44, which is PFI 10. It just has 10 items that can give indication about personalities. The other solution which we are working on is the adaptive approach. So you may start from a baseline where, for example, where you have a general persuasion profile that shows, for example, use principle A with percentage 20%, use the other principle in percentage 30%. And after many interactions between the user and the system, you can adapt this persuasion profile. I'm not sure if my answer is clear, but adaptivity is one solution for this problem.
Thank you. Yeah, thank you very much. All right, it's a good point.
Thank you. Thanks for asking.
So I think I need to kind of do a transition to the overall discussion. So I suggest if there are any questions, we probably can handle it as a part of the overall discussion. Timing is very short.
Yeah.
So we only have 15 minutes. Wait, right? For 25 minutes. Oh, no, yes, 15 minutes only for the overall discussion. So everyone, please, let's try to, unless you're sitting on a beach or some other place where we really be green with envy, I welcome you to try to show your cameras. I am not going to show the slides for the closing session. I really like to get a discussion. So you can switch Zoom. Of course, if you're going through Zoom in a gallery view, and we can kind of try to do the last 15 minutes to discuss everything. So there are two sides of the discussion.
I don't think the people in the Wova app can.
Yeah, I know, but it's a shame, but at least some of us, the speakers, the organizers, may show their faces, and that
we will be able to see you.
If you like to be visible and noticed, right? Yeah, please do that. At least some of us will be there. So there could be two reasons for the discussion, right? There's something that the attendees like to discuss because you have bold issue or painful points, and we need to have space for that. And something which organizers really need, and they need feedback from the attendees. So I think we can do both, but I will, being selfish as an organizer, I will start from the prospect of the organizers, and probably can provide some feedback. So what we're trying to do, we're trying always to address different communities that explore the issues, human factors and human-centered recommendations. And you see that the whole workshop was the merge of the two different topics, which has some reasonably good correlation, decision-making and interfaces. And on the way, because we become more inclusive, we assembled a bunch of other topics, essentially trying to be the central point in RecSys conferences for everything human-centered. But we might be not, right? There's a bunch of cool topics like persuasion, explanations, user control, which we are exploring, right? Decision-making, and Martijn presented a very nice overview, how focusing on that big topic, we've been slightly shifting and different topics become the priority. Are we missing anything, right? So from the prospect of the attendees who are partly interested in user-centered ways, what might be missing? Other human-centered issues in the recommender system which never been represented at the workshop. Which community we should reach and specifically invite next year when we're in nice Amsterdam. This is the city of bridges. Which kind of bridges we need to build? All right, microphone is open.
Yeah, I have an idea. I'm thinking, you know, if you really take a user-centric perspective on recommender systems, there's no recommender system, right? People don't know that what they're using is a recommender system. They're using a system and it gives recommendations. And so I'm wondering if we need to focus or if we need to be more accepting or more encouraging of papers that use recommendations kind of as a thing kind of that powers some other experience rather than just giving people items to like, etc. And perhaps even focus on aspects of typical recommender systems that are not the recommendation. So maybe also think about search and exploration and things like that. So those are two ways in which we could broaden up, so to say.
Okay, thank you, Bart. Actually, it's a good point. I don't think we have much of the work like that in our field at all. We need to go to different fields which don't think they do work on recommender system. They do something like information retrieval, right? But in fact, they're doing recommender systems. It will be changed to find them. Right, anyone else?
If I can
just have, sorry, Alexander, may I say something?
Yeah, Alexander, yes, please.
So it's just related to the comment of Bart. So I also find this extremely important to exploit recommender systems in different contexts, so to achieve specific goals. So for example, there is a scenario in group recommendation. So for example, in software engineering, you want to assure that decisions regarding requirements that are implemented are optimal. So you should really find the requirements that are the most relevant ones. And in order to assure that, you need a recommender system that does not just confirm preferences of the stakeholders in the software project, the recommender system should somehow figure out there is an issue in the group decision, and stakeholders should discuss more before they take the final decision. So it's, from my point of view, extremely important in different application domains.
Thank you, Alexander. For everyone who is not able to ask questions by voice, maybe you still can ask questions in the closing remarks session. I'm monitoring the whole application. All right, is it so? Any more people with feedback? Feedback on what we're missing, what else we would need for our kind of struggle to get to the system of human-centered.
Yeah, so I think for me, a recommendation is an advice. And I never see that perspective in our community that much. In our community, a recommendation is a prediction. And there were some good examples today. For example, actually the social network example was a nice one, because it's actually advising what are the best people to meet to actually extend my network and maybe become a better scientist and be more successful. So in that case, it's an advice to improve in some way. There are many cases like that, and that's just a different problem. And the other thing is that since it's just an advice, it also means that you might be wrong, and you might have to interact to basically get the recommendation better. That's if you go to a shop and the guy in the shop tells me you should buy this, and I say no, like the old conversational stuff and there's a lot of work done in the past, of course, that fits this framework, but we sometimes forget a little bit about it, especially now in the field. If you look at the main conference, which is very focused on large data sets, very how do you say that? There's a lot of focus on online evaluation, which is good, but it's also basically trying to adapt to basically use all the behavior and do some fancy optimization on some metric, but it's not really about the goals that users might have.
Well, I guess we all agree about that's why we did this workshop. And
but I see the main conference things have changed quite dramatically in the last years. If I compare this conference to 2018, there's not many user-centric topics anymore in the main conference.
Yeah, Martin, I think you're right. I don't know how much you can change next year.
I'm not a program chair, but
I was the program chair last year. We really fought with our colleagues to get a few user-centered.
Yeah, but I think it's not. Of course, it's probably also where the field is moving in some way, and in some way it's good. But we need to have everything.
Yeah, well, one of the communities we might breach, although I don't think we need to struggle very much, is intelligent user interfaces. So because it's kind of really hard to get interface-related work in mainstream RecSys nowadays, people more frequently go to IUI. Of course, the user modeling, which is much more user-centered than RecSys conference. So that's a challenge for us. So instead of bringing people to us at this conference from other place, maybe we should say, oh, they in a better place. Let's go and join them. All right. Okay, that's. I think I used half of the time. So now the prospects from the attendees. Anything else you need to discuss? Ask questions to any speakers, organizers, feedback. Again, microphone open. Your prospect now. And again, we can put it in Hoover. If I have my tablet, I can see what people are typing in Hoover.
One thing that Martijn mentioned made me think, which was he was saying, well, sometimes we get it wrong and then we need to be able to control the recommendations. It made me think, when do we need control, right? And when do we need transparency? Because we don't talk about that enough, I think. When I teach my human-computer interaction class, one of the first classes I show the students a screen that has a single button on it that says, do what I want. And then I ask people, is this the perfect user experience? And I say, you know, it's actually not the perfect user experience. There's one thing wrong with this. and I ask them what it is, and they usually don't get the answer. But the answer is you still have to press a button, right? That's the problem. But you know, obviously that's facetious, because that only works if a system exactly knows what you want and then can do what you want. But it kind of points to the fact that, you know, if you want a good recommender system, it needs to know what you want. But if it doesn't, then you can control anyway. That's the question.
Oh, yeah, I agree. Probably we need more work. We as researchers in user control, for example, we really need to create situation when control is important. And then we show that in this situation, user control is great. Satisfaction, trust. But that's actually challenging thinking, like the workshop with everyday people, right? Do they need this control? Actually, do they need transparency? So it reminds me about the classic Google interface. I feel lucky, just one button, and yeah, you need to press it, right? But just one. And you might notice there were a number of, for example, search system, which gives user more complexity, power over their search. Google bought all of them. I don't know whether they bought them just to get rid of the competitors, or they honestly wanted to do it a part of the Google search. And none of them worked, right? So Google search is pretty much the same as I was using back 30 years ago in my teletype, right? Line of the query in, a bunch of lines out. Not much of the control, transparency, explanations, whatever. Yeah, so I think somebody need to answer that. And that we probably, it's a appeal to the attendees. Can we show that the same control is not good for one category of users and good for the other category of users, depending on their preparation, intentions, time they can spend on the task?
So sorry, I dropped out while I was asking that question. But yeah, we did work on that.
Oh, that's too bad.
Martijn and I worked a little bit on like different types of control for different types of people, right? But I think there's a lot more work to be done on that. Yuka, did you have a suggestion for that?
Well, it is related. So I just wanted to like reiterate the need for like a few of my colleagues that would go to CHI, that are looking at user experience. They are very good at designing user interfaces. They want to be picky about the user evaluation. I would really add to the diversity of this community. Of course, my view to this is very limited. I'm only here for the first time, but I think you would enjoy what they have to say, and maybe they are a bit intimidated by the whole notion of recommender systems as the whole thing, which is maybe the perception is indeed that you need gigabyte, billions of data points, and then you cross with your state-of-the-art AI algorithms and that type of work. And I was positively surprised by this kind of human-centered. So actually you can talk about human-centered topics. I think I'm definitely spreading the word. So user experience, user evaluation, information visualization, great things. And I'm sure that they are visible here and present, but yeah.
Thank you, Yuka. Well, again, thanks to everyone. I have this kind of big screen. It used to be like 50 attendees, and they dropping and dropping. Now 24 left. I think it's really time to close the workshop. We have 1 minute left. So I thank you very much to everyone who attended, presenters, speakers, organizers. We really like to do another one in sunny Amsterdam next fall, and that will be a shame not to do it because Martijn is the chair of the conference, and you will give us the best room. I hope. Hopefully. So I guess I'll see everyone in a year.
Yeah, I might not have the time to actually contribute much to this workshop then, but we'll see.
I'll be happy to help out, you know. Never a bad idea to travel back.
All right, home. Bart, you might replace Martijn. He will be busy with the main conference. All right. Again, thanks for everybody.
Yeah, thanks all.
Good evening to Sam.
You.
Good afternoon.
Thank you. Bye.
Thank you, guys.
Bye-bye. Bye-bye.